Welcome to Section 2. In Section 2, we'll be focusing on management of safety and health. And it's very important, this section is very important because it helps us to understand that the management of safety and health has to be in a proactive manner. That is, you can't just manage safety and health in a haphazard fashion. You have to be deliberate, you have to have a definite plan of action. So in this section, we'll be discussing on occupational safety and health management systems. There are already established systems that are global standards, if you like, best practices by which you can tailor the management of safety and health within your organization too. We're going to be discussing that framework, which is the Plan, Do, Check, Act Cycle, PDCA, and then we'll look at some frameworks that are globally accepted, as standards for management of safety and health, including the ILO OSH 2001, the ISO 45001, and the HSG 65. About it, it's important that you don't just have knee-jerk reactions to issues or accidents and illnesses or what have you in the workplace. You need to have a definite plan of action. You need to have a proactive approach. A way to actually do that is to align the management of safety in your organization to already established standards. Now, we have some standards that exist already, like the ILO OSH 2001 by International Labour Organization, like ISO 45001 by ISO, like HSG 65 by Health and Safety Executive in the UK. Now, all of these standards are interestingly patterned after the framework which we call the PDCA, Plan, Do, Check, Act Cycle. And that's what we're going to be examining in this section of our course. As I mentioned, it's important to have a proactive approach to managing safety. And so what typically you would have is that you would have what we call a safety and health program, which usually will be patterned after a standard. It is not mandatory that your safety program is patterned after an established standard like the ILO or the ISO 45001. But of course, it is recommended because these standards have been checked by experts and they have been seen to be very effective. So essentially, for safety to work, you need to have a safety and health program within your own organization, which may or may not be patterned after a standard. But let's talk about what a safety and health program is. You must note that in having a safety and health program, just like I mentioned, that you cannot afford to have something haphazard or something based on just knee-jerk reaction reacting to incidents and accidents. So it has to be systematic, It has to include the entire organization. It has to be well thought through. A health and safety program is a definite plan of action designed to prevent accidents and occupational diseases. Remember, we're talking about your approach to managing safety. Some form of a program typically is required under occupational health and safety legislations in most jurisdictions, meaning that most jurisdictions would require you to have some sort of program to show that you are appropriately managing safety well within your organization. A health and safety program must include the elements required by the health and safety legislation also as a minimum. Essentially, the safety program is the system by which you build a safety culture, by which you develop a safety culture, and it's typically based on this highlighted principles and philosophy, which means that your health and safety program must be supported by safety policy. We're going to discuss what a safety policy is in a few sections from here. A health and safety program is achieved through safety audit, or what you may call assessment of the facility. Remember when we're talking about principles, the 8 principles in the recap of HSC1 earlier on, we did talk about the fact that there must be site-specific audits, that your program or your plan must be specific to your site or the hazards within your own work environment. So a health and safety program must be achieved through safety audit of your facility. It must be site-specific. The system must be created and implemented, of course, for it to work. The health and safety program also should be based on behavior-based safety. Again, in the course of our discussion in this class, so you want to ensure that you go through this entire course, we're going to discuss behavior-based safety is a critical element of effective health and safety management. And then you must also realize that a safety manager is not a safety program. What do we mean by that? In a lot of organizations, you hear something like when a situation happens or an incident, or people will just call out and say, safety manager, safety officer, where are you? Something has happened. No, the fact that you have a safety manager within your organization or safety officers, that is not sufficient to say that is all of our effort and all of the program we're going to have. A health and safety program, like we said, has to be all encompassing, all involving. Everyone has to be involved. Everyone has roles and responsibilities. It is not limited to one person or one safety manager or only the safety department. So that's what we mean by a safety manager is not a safety program. And also a safety program involves the buy-in of all employees within the organization, from top management to the very last or least worker in the organization. Of course, note that the elements required by the health and safety legislation within your jurisdiction must be included in your health and safety program as a minimum, as I earlier said. It's also important that there is employee involvement in the development of the plans, programs, and policies, as well as procedures that are within or that make up the safety and health program. It's also important to note that just because a regulation doesn't require some plans or programs does not mean that your organization would not include those plans and procedures within your health and safety program if it is needed. And that's why there is a need to do your own risk assessment to create your own health and safety program, because your risk assessment typically would reveal all that needs to be within your health and safety program. So what I'm saying in essence, and we're going to talk about this a bit more later on, is that risk assessment is more encompassing, and usually it goes beyond just the legislation. And that's why you would find that in most jurisdictions, legislation would be prescriptive, but beyond being prescriptive, legislation would also ask that you must do risk assessment, determine what may hurt people within your organization, and ensure that you protect people from those things. For health and safety program, like I mentioned before, organizations may rely or leverage on an established framework or standard as a guide for creating their own health and safety plan for their organization. This typically is called an occupational safety and health management system. Okay, and it is built, like I mentioned, based on the PDCA, that's the Plan, Do, Check, Act philosophy or framework. Established framework or standard as a guide for creating a plan for their organization in terms of management of health, safety, and environment. Of course, I'd said that this can be called an OSHA, occupational safety and health management system. So in terms of how the PDCA works, it's a cycle or a circle of continual improvement, meaning you plan, you do, you check, and then you act, and then you start again and again until your processes and the system that you have established matures to a level, which I'm going to show you in the next slide, that you are able to become very effective in the delivery of the objectives of occupational safety and health. So in planning, you plan what you are doing or what you're going to do. In doing or in the do, you implement the new processes, often on a small scale if possible. So you do what you said you would do, and then in checking, you check that you did what you planned you were going to do in the correct way. So you check whether your implementation was good. That's to measure the processes and compare the results against the plan to ascertain if there were any differences. And if there are differences, that's where acting comes in. So you act on anything that went wrong to avoid errors of the same nature. So essentially, when creating a health and safety program patterned after the PDCA cycle, it means that your program is going to be structured in such a way that you have a plan, then you execute. So you have structures, processes, procedures that help you to execute. That is the do. Then you have structures, procedures, processes that help you to check and then to act. So the idea of patterning your health and safety program after the PDCA is that you are going to make arrangements, and that's why we call it the management system. You're going to make arrangements within your organization, which includes processes, tools, procedures, people, that would ensure that there is a plan, okay, determining and defining what is to be done. There is the execution, there is the checking, and then there's the acting. And the essence of the PDCA, like I mentioned before, that it is based on continuous improvement. The essence of the PDCA is that you are able to move from one level of maturity to the other. And so this diagram, this maturity model, helps to see how implementing the PDCA would actually help you to move from a state where possibly you have unpredictable and reactive approach to management. That's the initial state where work gets completed but it is often delayed and over budget, to a stage where you're able to appropriately manage, to a state where you now have defined proactive rather than reactive approach to work, to a stage where you were measured and controlled. And the ideal stage after going through several cycles of plan, do, check, act is to have an optimized state, or to be in a level where you're stable and flexible, where the organization is focused on continuous improvement and is built to pivot and respond to opportunity and change. The organization's stability provides a platform to opportunity and innovation. That is the idea behind adopting a defined plan and a system that ensures that you are able to continually deliver value as far as safety is concerned. Of course, you realize that the PDCA is not limited to safety. You use the PDCA across many areas of business. Now, this is a diagram that shows the ILO OSH 2001. The detailed document of the ILO OSH 2001 is attached to this course, and you can download and have a wider view of the content. Now, this shows that the ILO OSH 2001 is actually patterned after the PDCA cycle, and the policy element, the organizing and the planning, represent the plan aspect of the PDCA. The implementation represents the doing aspect, the evaluation, the check, and the action for improvement, the act. You would find that the elements stated under the policy, organizing, planning, and implementation, evaluation, and action for improvement are those elements that help to fulfill those purposes. So for instance, on the policy, there's expectation that there should be an OSH policy wherein there should also be worker participation, which talks about roles and responsibilities. In the organizing, there's also responsibility and accountability, and then there's competence and training, as well as documentation and communication. Now, all of these elements under the Plan, Do, Check, Act aspect of the OSH management system would help you as an organization to plan for how safety is going to be managed within your organization. As mentioned earlier, the ISO 45001 is also another standard based on the PDCA cycle, and which is an occupational safety and health management system that your health and safety program can be based on. So the ISO 45001 can be adopted by any organization wishing to implement a formal procedure to reduce the risks associated with health and safety in the working environment for employees, customers, and the general public. So here you also find a depiction of the structure of the ISO 45001. Again, as earlier mentioned, this management system or this framework is also created in such a way that it aligns with the plan, as you can see, the do, the check, and the act. That's the plan, do, check, and act cycle And the ISO 45001 developers have created processes, procedures, and tools and techniques, essentially processes and procedures rather, to help you fashion how you manage health and safety in the workplace after this standard. So ISO 45001 is an internationally recognized assessment specification for occupational health and safety management system. Essentially, it's developed by a selection of leading trade bodies, international standards, like I said earlier on, it's best practice. And also the ISO 45001 has been designed to be compatible with other ISO standards like the 9001, which is for quality, and the 14001, which is focused on the environment. You would find that the standard or the management system addresses planning for hazard identification, risk assessment and risk control, the management program structure and responsibility as well, training, awareness and competence, and a number of other elements that we're going to discuss later on. Essentially, what this provides for those that desire or that decide to align with it is that it gives a guide on how safety and health can be proactively managed within the organization. And very similar to that is the HSG 65. Now, the HSG 65, which is also the structure we have here, is also patterned after the Plan, Do, Check, Act cycle. And you can see that there is also the policy element, the planning element on the planning, just like we saw in the ILO OSH 2001. There's the risk profiling, the organizing, and the implementation of the plan under doing. And then there is the measuring of performance. And of course, you go on to Act, where you look at the lessons learned and also ensuring that there is some sort of ensuring that you review the performance as well. The HSG 65 is Health and Safety Executive. Health and Safety Executive is the body responsible for the management of health and safety within the UK. And so the Health and Safety Executive's guide that explains the Plan, Do, Check, Act cycle approach to health and safety management. Also, it shows how it can help you as an organization, or you working within an organization that is saddled with the responsibility of managing safety, to achieve a balance between systems and behavioral aspects. The HSG 65 treats health and safety management as an integral part of good management generally, rather than as a standalone system. And that, like I said, is the focus of having a management system approach to occupational safety and health in the workplace. That is, you don't want to look at it as a standalone. You don't want to look at it from a knee-jerk reaction position. You want to be systematic about it. You want to have a proactive approach. You want to have a well-defined plan to managing safety in your organization. The first of the program elements to be examined is the policy. As you already know, a health and safety program is a definite plan of action that is designed to prevent accidents and occupational diseases. Of course, some form of a program is required, as earlier mentioned, under occupational health and safety legislations in most jurisdictions. A health and safety program must include elements required by the health and safety legislation as a minimum. So when we talk about program elements, essentially we're talking about what are the items or the procedures required, or the processes or the arrangements that have to be within your program or your management system that will help you address the requirements of legislation or address the objectives set by your organization in terms of occupational safety and health. While organizations will have different needs and scope for specific elements required in their health and safety program, and this typically will be based on the specific hazards that the organizations face and also the specific environment or industry that an organization exists in. There are, however, some basic items that are expected to be included in the program to ensure the goal of a health and safety in the workplace is achieved. So they include things like individual responsibility, occupational health and safety committee, health and safety rules, correct work procedures, employee orientation, training, workplace inspections, reporting and investigating accidents, emergency procedures, medical and first aid, health and safety promotion, and then there's some workplace specific items that we'll also be discussing. So the idea basically is that these elements as a minimum should be a part of your health and safety program. The first of such elements is the policy, and we're going to be discussing the policy first. An organization's occupational health and safety policy is a statement of principles and general rules that serve as guide for action. Senior management must be committed to ensuring that the policy is carried out with no exceptions. So essentially, the health and safety policy of an organization is what guides the organization. It's what gives direction. It's that statement that proceeds from top management and tells everybody or sets the tone of how safety and health is going to be managed within the organization. So the health and safety policy should influence all the activities within the organization, including how people are selected, what kind of equipment are used and the materials used in the work that is done, the way work is done, and how work is designed, and how goods and services are provided. The health and safety policy should have the same importance as any other policy within the organization. The policy statement can be brief, but it should mention a number of things. This includes, it should mention and clearly state management's commitment to protect the safety and health of employees, the objectives of the program, the organization's basic health and safety philosophy, who is accountable for operational health and safety programs, the general responsibilities of all employees. It should also state that health and safety shall not be sacrificed for expediency, and also that unacceptable performance of health and safety duties will not be tolerated. This serves as a sort of guide for how you can fashion the health and safety policy statement for your organization. The policy also should be stated in clear, unambiguous, and unequivocal terms. It's important, in fact, it is mandatory that the policy be signed by the incumbent chief executive officer, meaning that gives it management weight. It puts management weight behind it, and it shows that health and safety is priority to the organization. Remember, one of the principles, 8 principles of effective workplace safety and health, is management responsibility. It must be kept up to date, meaning that the fact that you write a policy today, you don't keep it for years and years without updating it. It is a document that must be reviewed over and over again. Remember also that we said you should follow the plan, do, check, act pattern. So it means that when you plan, part of your planning is creating the policy, isn't it? Then it means that you execute, that's the doing. You check how it's been executed, and then you act. So oftentimes in the checking aspect, one of the things you're going to be reviewing and checking for effectiveness is the policy. And if there's a need for some sort of updating of that policy, then that will be done. So that's why we say it must be kept up to date. Communicated to each employee. So the policy should not just be in a shelf somewhere. It must be communicated, either by having all employees have them on their computers, or sent to them, or as part of the onboarding process. There are different ways by which organizations communicate the policy to their employees. But what is critical, in some instances you find organizations placing the policies at the entrance of the facilities or their offices, placing it as a screensaver on their desktop, putting it as part of the ID cards. All of these are ways by which the policy is communicated. The key thing is that it must be communicated to all employees, and then adhered to in all work activities. We have attached here in this section an example of an operational health and safety policy statement, which we're going to see in the next slide, but also guidelines for creating occupational safety and health policy, and you'll be expected at the end of this section to actually create one as an exercise. So here is a very basic policy sample for XYZ Transport to all employees, January 1, 2010. At XYZ Transport, the safety and health of our employees comes first. Management is committed to doing everything possible to prevent injuries and to maintain a healthy environment. You see that a number of the elements mentioned earlier on are adhered to in this policy sample. You would notice that there's an attempt to ensure that this policy is clear, stated in unambiguous and unequivocal terms. When we read through this policy, you'd also find out that management's commitment to protect the safety and health of employees is clearly stated, and you can see it in that first paragraph. At XYZ Transport, the safety and health of our employees comes first. And that's one of the things that we mentioned a few slides before now in terms of what your policy should entail. The objectives of the program should also be there. You notice that is going to be in this sample. The organization's basic health and safety philosophy. Of course, by stating that the safety and health of our employees comes first, already is giving an idea of the philosophy, the thinking of management as far as safety and health is concerned. Management is committed to doing everything possible to prevent injuries and to maintain a healthy environment, also speaks to the philosophy. And then when you go on to look at all supervisors, that is to this end, all supervisors are responsible for ensuring that the employees are trained in approved work procedures to obtain optimal output without accidents and injuries, and to ensure that employees follow safe work methods and all related regulations. That is already fulfilling that aspect that we talked about as per stating responsibilities of all employees. And so you find that this sample policy attempts to mark or check all of those items that I had mentioned earlier on that should be contained in a policy statement. So this is a simple one. Your organization's own can be much more elaborate than this, but because it's a statement, it's something you want to create to give direction, to act as an overall document that portrays what the organization is all about as far as health and safety is concerned. It shouldn't be too voluminous. This is the policy statement. There will be other policies addressing different issues within the organization as far as health and safety is concerned. But this policy that we're talking about is the overall policy statement that guides how health and safety is managed within the organization. Joint health and safety committees if they're asked to do so. So essentially you find that workers are meant to ensure that they do all that is required of them to keep themselves safe and to keep others that work with them safe as well. Then we also have, interestingly, the responsibilities for safety coordinators or those that are in the safety department. So people like you and I who are in the safety profession. Interestingly, you find that the responsibility of safety coordinators actually have to do with ensuring that the system works and ensuring that the personnel in the organization are well trained and there is appropriate management of the system. So see examples of the responsibility of safety coordinators. And the reason why I'm emphasizing this is that when you compare these responsibilities to the responsibility of first-line supervisors, a lot of times there's a confusion between the responsibility of safety coordinators and what first-line supervisors should actually do. Many people confuse what first-line supervisors should be doing to what safety coordinators should be doing. No, it is first-line supervisors that have the responsibility to ensure safety on the shop floor at the place where people work. The responsibilities of safety coordinators would include things like advising all employees on health and safety matters, coordinating interdepartmental health and safety activities, collecting and analyzing health and safety statistics, providing health and safety training, conducting research on special problems, attending health and safety committee meetings as a resource person. So essentially, the safety coordinator is to help the workers and the supervisors ensure that safety is implemented by supporting them, giving information, giving training, helping with adequate research to help them to create an environment where safety works within the organization. Also note that safety coordinators can be known by different names in different organizations. Okay, so you find in some organizations they are called advisors, some supervisors, some coordinators, some managers. But their role essentially includes advising, like I said, coordinating, collecting, and analyzing statistics, providing training, information, and awareness, and managing stakeholders towards supporting safety initiatives. They're focused on promoting safety in the organization, and this can be done using different tools and techniques. This includes the use of meetings, like the toolbox or tailgate talks, signs and signals, pamphlets, as well as safety newsletters, and so on and so forth. So just a quick word about tailgate meetings. So the term tailgate meeting comes from the practice of meeting around the tailgate of a pickup truck on site. A more generic and perhaps a more popular term for this is toolbox meeting. While one could argue that there are slight differences covered in meetings that are on site, the main point is that the group meets on a daily basis to keep safety top of mind. So a tailgate meeting essentially is an informal safety meeting which is generally conducted at the job site prior to the commencement of a job or work shift. Job supervisors can draw attention to hazards, processes, equipment, tools, environment, and materials to inform all workers of the risks in their surrounding. Typically, you find that tailgate meetings are short, 5 to 15 minutes safety talks that refresh knowledge, and they're an excellent way to keep safety front of mind for everyone. And like I said, they're sometimes called toolbox talks, tailgate talks, or safety briefings. Lastly, on our discussion in OSH responsibilities is the Safety and Health Committee. An effective safety program needs the cooperative involvement of all employees. I said earlier when I was talking about the safety program, I said employee involvement is key. So an occupational health and safety committee is a forum for cooperative involvement of employees representing both labor and management. Such committees are statutory requirements for organizations of a specified minimum size in most jurisdictions. So in most regulations and legislation, you find that there is a requirement that organizations of certain sizes must establish a health and safety committee, and they may even go ahead to stipulate the number of people that can be part of the committee and what the roles and responsibilities of such committees and the members are. And the responsibilities, like I said, of members are generally spelled out in these health and safety legislation. So it's important that in any organization for safety to work, that responsibilities for all the people within the organization as far as safety and health is concerned are very clearly spelled out. They are communicated. The authority for personnel to actually implement these responsibilities is clearly delegated to them by management, and the required training is provided so that they can actually deliver on the responsibilities that have been placed on them. Health and safety rules as well as work procedures form part of the program elements that help to achieve the goals of having a safe and healthy workplace. So we're going to look at some of those health and safety rules and how to go about ensuring that you appropriately set health and safety rules within your organization and also establish correct work procedures. Government health and safety regulations obviously would represent minimum requirements for setting health and safety rules within your organization. In almost all cases, organizations will have to augment these regulations with specific rules. Again, this brings to bear the idea of risk assessment. Of course, based on an assessment of risks within your own organization, you would definitely come up with rules that will help you maintain a safe and healthy work environment. These rules must be followed to achieve a healthy and safe workplace. Rules will differ from organization to organization, but there are some general guidelines that typically will be helpful. So some guidelines to consider would be that rules should be specific to health and safety concerns in the workplace. Of course, this also speaks to risk assessment. It must be specific to the concerns. You can't just bring rules from another organization or another facility and dump on your own people. The Joint Occupational Health and Safety Committee should participate in the formulation of rules. That is speaking to employee participation. It's important that the input of employees and management come together to form rules so that the rules are acceptable and everyone has a sense of ownership. Of course, that would help to ensure that everyone adheres to those rules. Rules should be stated in clearly understandable terms. It's also important that rules are best stated in positive terms. That is, rather than saying employees shall not, it's better to say employees shall. So it is more positive reinforcement. The reasons for the rule should also be explained to employees. Remember, we're talking about guidelines, general guidelines for certain rules. And remember also that rules have to be based on the need of the environment, based on specific needs and peculiarities of the work or the environment or the organization in question. Okay, so the reasons for the rules should be explained. Rules must be enforceable. Now, you don't want to have rules that cannot be obeyed, okay, or that cannot be enforced in a scenario where it is probably not possible to be able to monitor a certain kind of behavior. You don't want to put a rule like that, and so whether employees obey it or not, it is not possible for management to check. Okay, and if it's not possible for management to check or for supervisors to be able to enforce such a rule, then it becomes redundant, and what happens is that there is a sense that employees begin to get that rules don't have to be obeyed. So it's important that the rules are enforceable, okay, since disregard for one rule will lead to disregard for others, like I've explained. Rules should be available to all employees in written form, and we have talked about communication earlier on, very important, and it should be in the language of communication of employees. So if employees in a certain work site are more familiar with a particular language, probably not the lingua franca of the country, maybe it's a local language, it's important that the rules are also communicated in the language that the employees actually understand and they can relate with. Rules, of course, should be periodically reviewed, as it is with all of the elements of the program, like we have talked about, plan, do, check, act cycle. So it should be reviewed to evaluate the effectiveness and to make changes for improved effectiveness. It's also important that there's compliance with health and safety rules to ensure that everyone is compliant. What I mean by that is that, just like we mentioned as part of the 8 principles, we said that working safely must be a condition of employment. Okay, so compliance with health and safety rules must be considered a condition of employment. Rules also must be explained to new employees when they start work, or if they are transferred, or if they are placed in a new environment, that is probably in a new role or with new equipment or what have you. Also, the employer should have procedures for dealing with those persons that flout rules, and particularly for those that also are repeat rule violators. To be able to enforce rules and regulations within the organization for safety to work, there has to be responsibility for ensuring this happens, and typically supervisors, in this case line supervisors, are responsible for correcting unsafe acts such as breach of rules, and they must be supported in this duty by management. A number of points to be considered in establishing procedures on how supervisors actually correct or enforce rules include ensuring that employees are aware of the rule. We've talked about that. Ensure that employees are not encouraged, coerced, or forced to disregard the rule by fellow employees. All rules are to be observed. No violation will be disregarded. The role of discipline is that of education, not punishment. That is, even though there will be need to create some sort of disciplinary measure for those that flout rules or violate rules, the role of such discipline must always be education, not punitive. Action must be taken promptly. While having guidelines for penalties for the first offender or infractions may be desirable, it's also important that there is some flexibility that is required in applying the guidelines, since of course each case will vary. So there has to be some emotional intelligence also placed or put in place or applied by supervisors when enforcing rules and when meting out disciplinary action. Action also in terms of disciplinary action should be taken in private and recorded. Closely related to rules and regulations in the workplace is work procedures. Now, work procedures are the safest ways of doing a job instruction, monitoring performance, and accident investigation. Essentially, we're saying that the best way to go about a particular job is what is considered as the correct work procedure. And in order to determine Now that is taking safety into consideration. That means the safest way to go about doing the job. Now, in order to be able to come to what the safest way to do a job is, we have to carry out a job safety analysis, JSA. Okay, in some instances we call it a job hazard analysis. It is the first step in developing the correct work procedure. In the job safety analysis, each task of a specific job is examined to identify hazards and to determine the safest way to do the job. The job safety analysis includes selecting the job, breaking down the job into a sequence of steps, identifying the hazards, and then defining preventive measures. The analysis should be conducted on all critical tasks or jobs as a first priority. Essentially, what this is all about is that for starting from critical tasks or jobs, there should be job safety analysis on all work that needs to be carried out in a particular organization or facility, and based on job safety analysis, correct work procedures must be developed, and those correct work procedures then form the basis of how the work will be carried out every time that work or that job is to be carried out within the organization. So it behoves on workers to follow correct work procedures for doing any work that has been assigned to them, and that correct work procedures will form part of the program elements to ensure that an organization operates safely. Training, employee orientation, and promoting employee involvement also are key parts of your program. So they must be part of your program elements. Essentially, they must be part of what you prepare to implement, you plan for, you provide procedures for in managing health and safety within your organization. So we're going to be discussing employee orientation. When we talk about employee orientation, we're talking about health and safety education or information, and this should start with employee orientation when an employee joins the organization or is transferred to a new job. It has been found that inexperienced workers in general are involved in accidents at a higher rate than others. So while experience can only be gained through time, both health and safety education and job skills training can be used to improve this record. So that's why training, awareness, orientation is very key. Orientation sessions normally cover such items as explanation of the functions of the work unit, organizational relationships, administrative arrangements, and miscellaneous policies and rules. Some of the items related to health and safety that should be included in employee orientation would be emergency procedures, location of first aid stations, health and safety responsibilities, including those specified by legislation, and you note that these things are actually included already in the program element. So it means communicating the program element itself to employees is actually a way of giving them, or is part of the employee orientation. Also, reporting of injuries, unsafe conditions and acts, use of personal protective equipment, right to refuse hazardous work, hazards including those outside of their own work area, and reasons for health and safety rules are some of the things that you expect to form part of the employee orientation in terms of the content that will be communicated to them. You would expect that a new employee can only absorb a certain amount of information in the first few days of joining the organization. So it makes a lot of sense to have a brochure outlining the points covered in the orientation session to be handed over to the employee as something to take away from the orientation and to be able to refer to after the orientation, because what is important is that the employee is able to retain the information, know these things, and be able to use them while working in the organization. Typically, employee orientation, as earlier discussed, is actually achieved via training of the either new employees. Particularly, the focus of employee orientation is new employees or employees that have been recently transferred to a new aspect of the business. So, of course, one of the key ways of doing that is training. Another way, like we discussed, is by providing booklets and brochures for employees to go ahead and look at by themselves. But it's also important to note that outside of the initial orientation, training has to be continuous within the organization as far as safety is concerned, to ensure that everyone is abreast of the information that they need in order to be able to work safely within the organization. A number of occasions when employee training may be required include when there's commencement of employment, like we had said earlier on, reassignment or transfer to a new job, introduction of new equipment, processes or procedures, as well as if inadequate performance is discovered. One of such ways by which inadequate performance may be uncovered is probably when there is an accident, an incident, or even a near miss. And when we discuss accident investigation, this is going to come to the fore again. Every program should have a way of promoting employee involvement. The question then is, how is this, or how can this be done effectively? Once the health and safety program has been set in place and the program is running smoothly, it's important that effort is put into maintaining enthusiasm and interest from the employees and everyone within the organization. Studies show that the effectiveness of health and safety educational techniques depends largely on how much importance management is seen to place on health and safety. So again, management responsibility comes in here, where management by its actions has shown that they are sincerely concerned. Interest in the program can be maintained at a high level. Accountability for individual performance, of course, is also a key motivator. A number of ways by which safety awareness and employee involvement can be enhanced include the following. So safety awareness can be enhanced by setting realistic goals and monitoring progress. Also, distribution of all pertinent information. Individual recognition for superior performance also helps to promote awareness and promote employee involvement. And of course, having general meetings, tailgate talks, and one-on-one coaching. Also, when you have well-designed incentive programs, all of these will help promote safety awareness and encourage employee involvement in safety in the organization. And this is a critical part of your program as well. Let's talk about safety inspections. Safety inspection is one of the areas that need to be taken care of also within the program elements. Of course, when we talk about the program elements, we're talking about all of those items that need to be included within your defined plan of action to successfully manage safety and health in the workplace. Safety inspections, in fact, is considered one of the key tools of the safety auditor or the safety manager, safety officer. That is, safety inspection alongside hazard analysis as well as accident investigation are key tools or key skills that the safety officer must have, because they are fundamental to the successful management of safety and health in the workplace. So in this model, we'll be looking at safety inspections. So what exactly is workplace inspection? Workplace inspections typically help to identify existing hazards so that appropriate corrective action can be taken. So the purpose of workplace inspection is to be able to take a thorough look, depending on the type of inspection, take a thorough look at the workplace in order to identify hazards that are present in the workplace. Health and safety legislation typically will require workplace inspection as a proactive action to ensure workplace health and safety. So in some jurisdictions, there will be guidelines provided for doing regular workplace inspection. That is, in some jurisdictions and in terms of the regulations existing in those countries or local governments, as the case may be, there will be requirements as per how regular or how often workplace inspections have to be done. Inspection of the workplace is an essential part of the health and safety program, as I'd mentioned before. And typically, when inspections are done, they allow you to cover a number of important areas of health and safety management. For instance, workplace inspection helps you as a safety officer or safety advisor to listen to the concerns of workers and supervisors towards improving the health and safety in the workplace. It also helps to gain further understanding of jobs and tasks. This would of course help towards creating correct work procedures and also improving the health and safety system, identifying existing and potential hazards, obviously, determining underlying causes of hazards, as well as monitoring hazard controls that have already been put in place. Later on in the course of this training, we will talk about hazard controls. And also, carrying out workplace inspections help the safety officer, safety committee, safety advisor to be able to recommend appropriate corrective action to take care of certain hazards or certain risks that may be present within the workplace. There are a number of inspections or types of inspections that can be carried out within the workplace. We have sports inspections. Sports inspections are essentially random inspections or inspections carried out on a random basis just to find out what hazards are present in different aspects of the work area. There's also pre-operation inspections. These are special equipment or work processes inspection before work is carried out. You could also have critical parts inspection. These are regularly planned inspections of critical parts of a machine, piece of equipment, or system which have a high potential for serious accidents. So you may also specifically want to carry out inspection of such parts. And of course, this kind of inspection will take place more often than other non-critical parts of the facility or of the machine. There's also new equipment inspection, which obviously will be carried out before a new equipment is deployed into operation. And then there are the regularly planned inspections, which are done on a regular basis and cover all conditions. These are what you may call regular or pre-planned or scheduled inspections, as the case may be. So how is workplace inspection done? Of course, there's a need to closely examine the workplace on a regular basis. And of course, depending on the type of inspection, as earlier mentioned, some may be on a regular basis, some may be spot inspections, some may be critical parts inspection, and so on and so forth. But the aim of all of this is to identify and of course record the hazards towards remedying the hazards, that is recommending controls for those hazards to be remedied. Now, when inspections are being done, you're looking out for two types of hazards. There is the unsafe condition as well as unsafe acts. Unsafe acts, of course, have to do with how workers are performing the work. So if someone were to be doing a certain type of job that requires some protection, maybe eye goggles or hard hats, and they're not doing that, that is an unsafe act. Or if someone were to be working in such a way that exposes them to some hazard, or they're doing certain jobs and they are, for instance, someone may be working in close proximity, maybe he's working with naked light and is working in close proximity to some fuel source, that is unsafe act as well. And then the unsafe conditions, which actually talks about the state of things. So if someone, or if you have within the facility certain things placed, so if you have ignition sources placed near fuel storage, then that's an unsafe condition. Or if you have machines that do not have their guards on, those are unsafe conditions. And so there may be several of those within the workplace. So when doing an inspection, the inspector, which may be someone that is working within that unit, so we're talking about either supervisors, workers, or safety experts or safety professionals, which may be the safety supervisor or the safety officer, anyone that is saddled with the responsibility of carrying out the inspection, then we'll be looking out for both unsafe conditions as well as unsafe acts. It's also important that the inspector does not just look out for the actual things that are in existence, that is the unsafe acts or unsafe conditions. They should also look out for the potential. So you should be able to look at scenarios and see what can happen or what can be, seeing the conditions or the situation of things as they are. Meaning you can look at some things placed on a particular platform and you can say, oh, it is possible for this thing to drop off. Okay, so it is better we place it in a way that we ensure we control the possibility of that thing dropping off or dropping on someone, or these occurring, and so on and so forth. So you need to look at the potential as well as the actual. And then when doing inspection also, you want to look at existing controls. Later on in this course, we'll talk a bit more about hazard controls. So you want to consider what is the status of the existing hazard controls. Are they in place? So for instance, a machine guard, a safeguard for a machine, or a sharp aspect or sharp object, or a rolling aspect of a machine, or a cutting element of a machine, there is usually a need to safeguard those sharp points. So if, let's assume, that is removed, okay, the safeguard is removed, so you need to look at it and say, or note that that guard is no longer functioning. Okay, so that's also one of the areas you look at for while doing inspection. Planning is essential for effective workplace inspection. There are a number of areas that you need to consider when carrying out inspection, that is areas you need to examine. Every inspection must examine the who, the what, the where, when, and how. It's important to pay particular attention to items that are most likely to develop unsafe or unhealthy conditions because of stress, wear, impact, vibration, heat, corrosion, chemical reaction, or misuse, like I earlier mentioned. Ensure you inspect the entire workplace area each time. You may also include areas where no work is done regularly, such as parking lots, rest areas, office storage areas, and locker rooms. It's also important that you look at all workplace elements, the environment, the equipment, and the process. Now, these are just guidelines on how to do proper, thorough inspection. When we talk about the environment, this includes such hazards like safety hazards, biological hazards, chemical hazards, ergonomic hazards, and physical hazards as noise, vibration, lighting, temperature, and ventilation. So all of these elements have to be looked at when carrying out an inspection. Of course, you also need to look at equipment, like materials, tools, things used for producing a product or a service. You also need to look at the process that is being carried out within the workplace. These processes may involve the things, how the workers interact with the other elements in a series of tasks or operations. Some of the information typically required to assist in completing an inspection report will include possibly the diagram of the area being inspected, inventory of equipment that are within that area, inventory of chemicals that are within the area. You may also require the use of checklists and also previous reports of inspections done in that particular area. During inspections, look out for deviations from accepted work practices, and when reporting, use statements such as, a worker was observed operating a machine without a guard. I talked about an example like this earlier on. Don't use information derived from inspections for disciplinary measures. Of course, this is important. The essence of inspection is towards recommending controls to improve the safety system or the safety and health of the workplace. There's some common poor work practices which can include use of machinery or tools without authority. These are things you're looking out for. Operating at unsafe speeds or in other violation of safe work practice. Remember, I talked about unsafe conditions and unsafe acts. So these are examples of unsafe acts. Removing guards or other safety devices or rendering them ineffective. These are examples of unsafe acts. Using defective tools or equipment or using tools or equipment in unsafe ways. Using hands or body instead of tools or push sticks. Overloading, crowding, or failing to balance materials or handling materials in other unsafe ways, including improper lifting, repairing or adjusting equipment that is in motion, under pressure, or electrically charged. Also, standing or working under suspended loads, scaffolds, shafts, or open arches. All of these are examples of unsafe acts, and they're things that while doing inspections should be looked out for. There are a number of inspection principles also that should be considered. For instance, ensure that you draw attention to the presence of any immediate danger. There may be other items or other scenarios that are not immediately dangerous to life and to health that you can put in the final report and then you await remedies afterwards. But there are certain things that when you see constitute immediate danger, then you must draw attention to them immediately. It's also important to shut down and lock out any hazardous items that cannot be brought to a safe operating standard until they're repaired. So you ensure that they're shut down so that they do not pose any threat beyond the time that they have been discovered. Do not operate equipment as an inspector. Don't operate equipment by yourself. Peradventure, you want to see how that equipment works in actual motion so as to be able to adequately know the condition of the equipment. Do not operate that equipment yourself. Ask the operator for a demonstration. And if the operator of any piece of equipment does not know what dangers may be present, this is cause for concern. So do not ignore any item because you do not have knowledge to make an accurate judgment of safety. Look up, look down, look around, look inside. Ensure that you're methodical and thorough when doing your inspection. Don't spoil the inspection with a once-over lightly approach. Don't be in a hurry. Okay, take your time and ensure you do thorough inspection. Ensure that you clearly describe each hazard and its exact location in your rough notes. Allow on-the-spot recording of all findings before they are forgotten. So obviously, when carrying out an inspection, you must go with writing materials, whether electronic or paper and pencil. Record what you have or have not examined in case the inspection is interrupted. So you need to keep a record of how far you've gone in the inspection. Ask questions, but do not unnecessarily disrupt work activities, as this may interfere with efficient assessment of the job function and may also create a potentially hazardous situation. Ensure you consider the static and dynamic, that's the stop position and the in-motion conditions of items you're inspecting. If a machine is shut down, consider postponing the inspection until it is functioning. Discuss as a group, peradventure if you're inspecting with a group. Discuss items like, can any problem, hazard, or accident generate from this situation when looking at the equipment, the process, or the environment. Determine what corrections or controls are appropriate. Do not try to detect all hazards simply by relying on your sense or by looking at them during the inspection. You may have to monitor equipment to measure the levels of exposure to chemicals, noise, radiation, or biological agents, meaning that you need to use equipment in some instances to know the exact situation of particular equipment or particular scenarios. Also, one of the principles you need to take into consideration when doing inspection is that you may need to take photographs if you're unable to clearly describe or sketch a particular situation. Still on safety inspection, another area to consider and to discuss is who should do an inspection. Typically, health and safety committee members are obvious choices of personnel to carry out formal inspection, especially if they have received training or certification. So essentially, the person that should do a safety inspection should be appropriately and adequately trained to be able to do an inspection. And such a person should be conversant with some of the things we've discussed earlier on what to look out for, on some basic principles of carrying out an inspection and how to go about carrying out an inspection, the tools and the resources that are required to carry out an inspection. Of course, the key criteria for selecting an inspection team should be knowledge of regulations and procedures, as well, knowledge of potential hazards, and experience with work procedures involved. So it makes a lot of sense for someone carrying out an inspection to be familiar with the area and the kind of work processes they would be inspecting. So if you like, you can say a competent person should be the one carrying out an inspection. So it could either be someone that is a part of the safety team, it could be someone that is a line supervisor, it could be a worker within that facility, it could be someone in the health and safety committee. So any of these people can carry out an inspection, provided they are adequately trained and they have the required knowledge to carry out the inspection. Another question to consider is, how long should an inspection take to do? While no one can accurately estimate how long each inspection will take, the time required to carry out an inspection will depend on what is found, how many questions are asked, and how large and complex the work area is. Inspections are ineffective when the given time allows for only a hasty look. Of course, the purpose of the inspection is to keep the workplace free of hazards. So as much time that is required, of course, reasonably so, also must be taken to carry out adequate inspection of the workplace. It is necessary, however, that inspections be scheduled except for spot inspections. Remember our types of inspections earlier discussed. And the schedule typically should state when to inspect each area or item within the workplace, who carries out the inspection, and also what degree of detail to inspect within each area. Also, one may wonder how frequent inspections should be. What should be the frequency of inspections? Now, the frequency of inspections will depend on a number of factors. The frequency of planned formal inspections may actually be set by legislation. So there are some jurisdictions that will stipulate that inspections be carried out quarterly or half-yearly, as the case may be. So it may be stipulated by legislation. Inspection may also be determined, or the frequency may be determined by incident records or past accidents. You may have a scenario where if an accident were to occur, that may trigger an inspection. Or if you find that in a particular work environment there is frequent, or you have frequent accidents, then you may have to do inspections more often, because that suggests that there are hazards within the workplace that need to be uncovered in order to forestall these accidents. Also, number and size of the different work operation may also determine the frequency of inspection. Type of equipment and work processes, you may have those that are hazardous or potentially hazardous, requiring more regular inspections. Number of shifts and the activity of every shift may vary, so the kind and the frequency of inspections may differ depending on those shifts. When there are new processes introduced or new machines may, of course, determine the frequency of inspections, and of course the perceived risk within the particular area. So high risk areas should receive extra or more frequent inspections than places considered as low risk areas. The results of inspections have to be communicated via reports, and this is important because the essence of safety inspection in the first place is to identify hazards with a view to remedying or controlling those hazards, and controls typically would have to be approved or resourced by management. So it's important that reports are generated as a result of inspections. Essentially, safety inspection reports are reports of risk assessment, and they should contain any unfinished or relevant information from previous reports. So you may want to bring over some items that are still pending in previous reports into your new inspection report. The safety inspection report should be specific to hazards identified and clearly presented in a way to make management aware of the problem in a concise and factual way. So how is the safety inspection report completed? Of course, depending on your organization, you may have certain formats that have been created by your organization to fill in a safety inspection report, but there are some general guidelines that can also help with how you fill in your inspection report. So if I were to be a bit descriptive and to give some guideline, I would say to make a report, first copy all unfinished items from the previous report onto the new report, then write down the observed unsafe conditions and recommended methods of control. You also want to include the department or area inspected, the date and the inspection team's names and titles on top of the page or on the report, depending on where the space is. Number each item consecutively, followed by a hazard classification of items according to the chosen scheme for those hazards. So you may talk about whether it's physical hazards, biological hazards, or what have you. State exactly what has been detected and accurately identify its location. It's important that instead of just stating that machine was unguarded, it's better you state guard missing on upper pulley number 6 lathe machine in North Building, or in the can factory, or in the operations department, as the case may be. Also, you want to assign a priority level to the hazards observed to indicate the urgency of the corrective action. So you may want to assign whether it's a major issue, serious, or minor. All of these we're going to talk about a bit more when we discuss risk assessment later in this course. It's also important to make management aware in your report of the problems in a concise and factual way. Management should be able to, based on your report, understand and evaluate the problems, assign priorities, and also quickly reach decisions. Also, after each listed hazard, it's important to specify the recommended corrective action and establish a definite correction date or expected date for that action to be taken. Each inspection team, if this was done in a team, if each inspection team member should review for accuracy, clarity, and thoroughness. It's important to note that an inspection report sort of dovetails into a risk assessment report, and we're going to talk about that later on in this course. Finally, on inspections is follow-up and monitoring. And what follow-up and monitoring essentially is that after the report has been submitted and purportedly the corrective actions have been implemented, it's important to go back and check and review those actions that have been taken to ensure that indeed the corrective actions are effective and that they continue to keep the workplace safe and healthy. Welcome to this module on reporting and investigating accidents. It's also one of the program elements, which essentially says that it's one of those areas that you must proactively plan for in managing safety within your organization. Accidents and incidents are investigated so that measures can be taken to prevent the recurrence of similar events. You may be wondering what's the difference between accidents and incidents. We discussed that in HSC level 1, but I'm going to discuss that again after now. But just note that the essence of investigating accidents and incidents is so that recurrence can be prevented. Investigation represents an after-the-fact response for any particular mishap. However, a thorough investigation may help uncover hazards or problems that can be eliminated before the fact for the future. So if we do a thorough investigation now, we are working towards preventing mishap of a similar kind or of other kinds in the future. So that's why it's so important that accidents, incidents, even near misses, as we'll get to see, ought to be investigated. After causes have been determined, prompt follow-up action, of course, is required to achieve the purpose of the investigation. So what should be reported and investigated in case an accident occurs? Typically, occupational health and safety legislation in all jurisdictions require that injuries and certain categories of accidents must be reported. There may, however, be minimum legal requirements for their investigation. It's important to realize the value in investigating accidents and incidents. Many organizations investigate lesser accidents where damage did not involve injuries, and that is what we call non-injury incidents. And they also investigate near misses. Now, the health and safety program should specify when it comes to defining or detailing a program that addresses reporting and investigating accidents. These are some of the things that should be within that program or your defined plan of action. You should be able to state what is to be reported, to whom it will be reported, how it is reported or how it is to be reported, which incidents are investigated, who will do the investigation, what forms or templates are to be used, what training investigators will receive, what records are to be kept, what summaries and statistics are to be developed, and how often reports are prepared. This is a guide, and your organization can have beyond this, but these are elements within that program that are expected to be within your health and safety program as regards reporting and investigating accidents to help you maintain a good and an effective safety system. So let's consider some of these definitions for accident, near miss, incident, injury and non-injury accident, as well as reportable accident. The term accident is defined in the HSC publication, Successful Health and Safety Management HSG 65, as any undesired circumstances which gives rise to ill health or injury, damage to property, plant, products, or the environment, production losses, or increased liabilities. Essentially, this means that accidents are undesired circumstances that lead to some form of loss. The same HSG 65 publication suggests that the related term incident includes undesired circumstances and near misses with the potential to cause accidents. The key term here being potential. So it is particularly important to investigate incidents which had the potential to cause severe harm, even if the actual harm caused was trivial rather. So this is saying that an incident is an undesired circumstance, but it did not cause damage or injury or loss, but had the potential to do that. Now, in certain texts and in certain sources, you may find that the term accident and incident are used interchangeably. But if you want to be very particular based on this HSG 65 definition, then the difference between an accident and an incident will be that an accident actually causes loss, while an incident had the potential to cause loss. Now, related to that also is a near miss. The near miss would include circumstances that could have resulted in an accident, and we often refer to this as dangerous occurrence. So in this case, the event did not actually happen, but it almost happened. That is, the accident, the undesired circumstance almost happened or could have happened, but it did not happen. So that is considered a near miss. In addition, the terms injury accident and non-injury accident also need to be clearly understood. An injury accident involves personal injury and may also involve property damage. That means there is personal injury, that's injury to someone, a worker, and also property damage. While a non-injury accident involves property damage but no personal injury. And then we have reportable accidents. The term reportable accident includes those which lead to death,
specified injuries, specified illnesses, or incapacity for normal work for more than 3 days. Reportable accidents must be reported to enforcement authorities under the Reporting of Injuries, Diseases, and Dangerous Occurrences Regulation, that's REDOR 1995. Where a fatality occurs, the police also must be informed. Of course, you must note that in different jurisdictions, there are different requirements for accident reporting as well as investigation. Having considered the definitions for accident, near misses, incidents, and so on and so forth, let's look at what accident investigation is. Accident investigation is the determination of the factors contributing to an accident or incident, as well as the means to prevent a recurrence. From a health and safety perspective, the primary purpose of an accident investigation is to identify the causes of an accident in order to suggest remedial action which will prevent a recurrence, like earlier mentioned. This will often involve looking beyond the immediate or direct cause to the underlying or root causes. Only when all these have been identified and tackled can we claim to have taken effective action. Now, the reasons to investigate would include to find out the cause of accidents and to prevent similar accidents in the future, like I said, to fulfill any legal requirements. Practically all jurisdictions have some requirements for investigating and reporting accidents in the workplace. To determine the cost of an accident is also one of the reasons why you'd want to investigate, to determine compliance with applicable safety regulations, and also to process workers' compensation claims. It should also be noted that incidents that involve no injury or property damage should still be investigated to determine the hazards that should be corrected. The same principles apply to a quick inquiry of a minor incident and to the more formal investigation of a serious event. You may have heard this statement before, that accidents don't just happen, they are caused. Yeah, that's very correct. Accidents don't just happen, there are always causes to any accident that occurs. And in fact, if you recall, one of the 8 principles that we discussed in HSC Level 1 is that all accidents are preventable. And the reason why that principle is there is because we know that accidents are caused, and if they are caused, then they can be prevented. And that's why that principle says you must understand that all accidents are preventable. Accidents are rarely simple in terms of the causation, what causes them. It's never really only one thing, okay? Almost they never result from a single cause, like I've said, and they usually would involve multiple interrelated causal factors. That is the nature of accidents, and this is important because it helps you, if you understand the accident causation model or how accidents are caused, then it will help you to know how to properly plan for them and prevent accidents. When we talk about the causes of accidents, we have 3 types of causes: the root cause, the direct cause, and the contributing cause. Let's start with the direct cause. The direct cause of an accident is comprised of the immediate event or conditions that resulted in the accident. You may say the accident or incident itself. The direct cause usually will be stated, for example, as the accident was caused by contact between the screwdriver the victim was holding and the 480-volt energized electrical conductor in a circuit breaker. Now, that is the direct cause of electrocution for that particular personnel. That is an example of direct cause. Identifying the direct cause of an accident is usually simple and straightforward, but the direct cause is often not the most important factor in determining what actions may prevent future or similar accidents. Therefore, we need to consider the contributing causes as well as the root cause. Contributing causes are events or conditions that collectively with other causes increase the likelihood of an accident, but they did not individually cause the accident. Contributing causes may be long-standing conditions or a series of prior events that alone were not sufficient to cause the accident, but were necessary for the accident to occur. They can be said to be the conditions that set the stage for the accident, and if allowed to persist or reoccur, increase the probability of future accidents. For example, inadequate lighting in the work area created visibility problems that contributed to the contact between the screwdriver the victim was holding and the 480-volt energized electrical conductor in the circuit breaker box, as earlier mentioned. And now to root causes. Root causes are the causal factors that, if corrected, would prevent recurrence of the same or similar accidents. Root causes may be derived from or encompass several contributing causes. They are higher order fundamental causal factors that often address classes of deficiencies rather than single problems or faults. Correcting root causes would not only prevent the same accident from recurring, but would also solve deficiencies that could cause or contribute to other accidents. They are identified using root cause analysis. Of course, based on this description, it's obvious that root causes are the primary cause or causes of the accident. And if or when they are dealt with, then it will not be possible for those accident or the accident to reoccur because the root cause has been removed. And this is why it is important that accident investigation understands the accident causation model and attack not just the direct or immediate cause or contributing causes, but essentially uncover the root cause and address the root cause. You then discover that in many cases, root causes are failures to properly implement safety procedures. Root causes, for instance, can include failures in management system to define clear roles and responsibilities for safety, ensure the staff are competent to perform their responsibilities. That means a lack of training. Ensure that proper resources are available. Failure to ensure that hazard controls are in place and adhered to, as well as failure to ensure that work is properly reviewed and authorized. You'd find that a lot of times, root causes of accidents in the workplace are as a result of failure of management or of the management system. As earlier mentioned, accidents are caused, and often they are caused by more than one cause. And that's why we talked about root cause, we talked about contributing causes, and we talked about the direct cause. Accident causation models are useful in analyzing accident investigation findings. And we're going to look at a number of accident causation models. The following is a brief outline of some of the accident causation models that can be applied when investigating accidents in order to get to the root cause and uncover the causes of the accident with a view to remedying these causes to prevent recurrence of accidents in the future. We're going to be looking at the domino theory, the refined domino theory, as well as the tree diagram. According to the domino theory, the events leading up to an accident are like a row of dominoes as shown in the diagram from domino 1 to 5. Once one domino has been knocked over, the next event quickly follows. Notice that the accident and the injury have been separated in this diagram. This is because, although the accident often occurs at the same time as the injury, losing the top of a finger in a circular saw, for example, this is not necessarily always the case. In some instances, there are long latency periods that can occur between the accident and the injury. For example, between the accident of being exposed to a harmful chemical and the ill health, which may result between 10 to 20 years from the time of exposure. Based on this, you find that accident causation models typically would distinguish between the causes of the accident, and the resulting injury. The simple explanation of this domino theory essentially, in the way that it aids in investigating accidents, is to look at the number one domino, which is ancestry and social upbringing, saying the main or the fundamental or the root cause is the ancestry and social upbringing of the person. And of course, because the focus is on the person, then it suggests that there is someone that is at fault for an accident. The person goes ahead, and because the person has certain ancestry and social upbringing, would typically take part in unsafe act or unsafe behavior, and then the accident would occur, which will lead to an injury. Now, this domino model is of very little value in accident prevention terms, as it always focuses on the fault of the person. The person may be at fault though, but usually there are other causes involved as well, hence the need for the refined domino theory. The refined domino theory is also based on the same concept as the domino theory. That is, looking at the dominoes 1 to 5, starting from 1. Once 1 happens, then it goes on to 2 and 3 and 4 and 5. However, in this model, that is the refined domino theory, the model does not place the blame of the accident on the person. If you recall, in the domino theory, it was ancestral and social upbringing, and then the fault of the person, and then unsafe acts and unsafe conditions, then accident and injury. But in this case, the emphasis is on the management system. So the number one thing, which is at the root cause, which I'd mentioned earlier on, is the lack of management control, then unsafe underlying causes, which brings about unsafe acts and unsafe conditions, and then accident and injury. Unlike the domino theory, where the issues with that theory had to do with focus on one cause, focus and blaming of the individual, in the refined theory, we see that there is more emphasis on management failure, which HSE claim accounts for at least 75% of accidents. There's little emphasis here on individual failure, even though it still has a single causation approach. So let's look at the tree diagram, which is another accident causation model. And this is considered a more useful technique in analyzing the causes of accidents, because this helps us to look beyond just one causal factor. It helps us to consider the direct causes, underlying causes or root causes, and multi-causal analysis. And this essentially is what we refer to as the tree diagram, because it looks at multi-causal analysis of the accident. Careful use of this technique can lead to identification of direct causes, indirect causes, and underlying factors which contribute to the accident. A good approach to identifying these underlying factors is to use the technique known as MIP. This involves identifying underlying factors relating to the materials involved, the equipment being used, the environment being worked in, and the people involved. Now, in the tree diagram, the underlying factors are stated when you look at it from this multiple approach of materials, equipment, environment, and people. then lead to underlying causes and sub-causes of unsafe acts and unsafe conditions, which then lead to the unsafe act or the unsafe condition or both, and then to the accident and then the injury. So this represents the basic tree diagram used in multi-causal analysis. You would have noticed that in all of the models, the domino theory, the refined domino theory, and the tree diagram, unsafe acts and unsafe conditions ultimately lead to the accident and then the injury. A large number of accidents, of course, are caused by unsafe acts or unsafe conditions, or by a combination of both. Unsafe acts often relate to human factors, such as competence, motivation, attitude, and perception. They need to be addressed by controls, such as culture, training, awareness raising, involvement, empowerment, and ownership of safety problems. Unsafe conditions, on the other hand, often relate to physical problems such as lack of machine guarding or high level of airborne contamination, and these need to be addressed through engineering and physical controls. Again, we'll talk about controls a bit more later on in this course. Only when a safe person works in safe conditions will the potential for accidents be greatly reduced. Therefore, accident investigation needs to concentrate on both unsafe acts as well as unsafe conditions. Another concept that helps with accident investigation and understanding accident causation is the accident triangle. Studies by various experts, as revealed in these three triangles, reveal that without proper control, near miss and incidents will eventually result into fatal accidents. For instance, when we consider the Enrich 1950 accident triangle, Enrich says that 300 no-injury accidents, if nothing is done about them, will lead to 29 minor injuries and then lead to 1 major lost time injury. This underscores the importance of investigating all accidents. So as seen from the findings of Enrich, Bird, as well as Tai and Pearson, although we see that the figures below vary, or the figures for each of these accident triangles vary from study to study, the basic principles remain the same. The no-injury incidents or near misses in each case have the potential to become events with more serious consequences. However, not all near misses involve risks which might have caused fatal or serious injury. What all the events do indicate is the failure of control. That is, if the near misses at the base of the triangle are not prevented or they are not controlled, then they will lead to more serious injuries and eventually to fatalities. Therefore, the near misses at the base of the triangle provide for us opportunity to prevent accidents from occurring. So if action can be taken at this level, then the chances of more serious injuries occurring will be greatly reduced. Let's talk about who should carry out accident investigation and how it should be done. Ideally, an investigation will be conducted by someone experienced in accident causation, experienced in investigative techniques, fully knowledgeable of the work processes, procedures, persons and industrial relations environment of a particular situation. You may also find that some regulations specify who should be involved in accident investigation. In most cases, however, we find that the supervisor should help investigate the event. Other members of the team can include employees with knowledge of the work, the safety officer or safety advisor, health and safety committee members, union representatives if applicable, employees with experience in investigations, and you could also involve outside experts or representatives from the government, most likely the local government. The key qualification, however, is that a competent person, by reason of training and experience and knowledge of the particular environment, should be the one investigating or should form part of the team of investigators for an accident. So what should happen immediately after an accident is discovered to have occurred? The following steps should take place following an accident or incident. Number one is that treatment should be obtained for any injuries. Then the area should be made safe following the incident, except where the accident results in a major injury, in which case the scene should be left undisturbed until advised otherwise by the enforcing authority. Then enter the details of the accident in the accident book, that you should record that accident. Then inform the injured person's manager or other responsible persons. Then keep informed of any after effects of the incident, including periods of total or partial incapacity for work. And the next will be to carry out an accident investigation with the primary purpose of identifying the causes in order to suggest remedial action so as to prevent a recurrence, and then review existing workplace risk assessments and safe systems of work, bearing in mind the accident investigation results. These essentially are the steps to take when an accident has been discovered or when an accident occurs. The most important immediate tasks include rescue operations, medical treatment of the injured, and prevention of further injuries. These, of course, have priority over any investigation that you may want to do. These are priority, and others must not interfere with these activities. When these matters are under control, the investigators can then start their work. As little time as possible should be lost between the moment of an accident or near miss and the beginning of the investigation, taking into consideration, of course, the need to first take care of injured workers or people that have been injured. In this way, one is most likely to be able to observe the conditions as they were at the time, prevent disturbance of evidence, and identify witnesses. The tools that members of the investigating team may need, whether it's writing material, cameras, or what have you, should be immediately available so that no time is wasted. This means there has to be some prior preparation for these resources and tools to be made available in case they are needed for an investigation. So the steps in investigating the accident would include gathering of information, analyzing the information, drawing conclusions, and making recommendations. The first step, as mentioned, in any accident investigation involves the gathering of factual information. This may involve plans of the workplace, drawings of equipment, and witness testimony. An investigation often adopts the following structure: establishing the essential facts, what happened, how, and where in the correct time sequence, uncovering the underlying causes in order to complete a multi-causation analysis, bearing in mind, as earlier mentioned, factors related to materials, equipment, environment, and people, MIP, as stated in the tree diagram under our accident causation model a few modules ago. The first step in accident investigation, as seen earlier, is information gathering information. And there are three ways in which you can do that, as stated here: physical evidence, eyewitness accounts, and background information. Before attempting to gather information, however, it's important to examine the site for a quick overview and take steps to preserve evidence and identify all witnesses. The first of the information gathering techniques, being physical evidence, is probably the most non-controversial information available. It is also subject to rapid change or obliteration. Therefore, it should be the first to be recorded. Based on the investigator's knowledge of the work process, one may want to check items like positions of injured workers, equipment being used, materials or chemicals being used, safety devices in use, position of appropriate guards, position of controls of machinery, damage to equipment, housekeeping of area, levels of noise and lighting, weather condition, time of day, etc. The investigator may also want to take photographs before anything is moved, both of the general area and specific items. Later, careful study of these may reveal conditions or observations missed previously. Sketches of the accident scene based on measurements taken may also help in subsequent analysis and will clarify any written reports. Broken equipment, debris, and samples of materials involved may be removed for further analysis by appropriate experts. Even if photographs are taken, written notes about the location of these items at the accident scene should be prepared. The second way to gather information is eyewitness account. Every effort should be made to interview witnesses. In some situations, witnesses may be your primary source of information because you may be called upon to investigate an accident without being able to examine the scene immediately after the event, meaning that you're not at that scene at the time. You may be called from another location, maybe from another area of the business. Because witnesses may be under severe emotional stress or afraid to be completely open for fear of recrimination, interviewing witnesses is probably the hardest task facing an investigator. To help you make a success of this, endeavor to keep witnesses apart and interview them as soon as possible after the accident, because if witnesses have an opportunity to discuss the event among themselves, it's likely that individual perceptions may be lost in the normal process of accepting a consensus view where doubt exists about the facts. Also, witnesses should be interviewed alone rather than in a group. One may decide to interview a witness at the scene of the accident where it is easier to establish the positions of each person involved and to obtain a description of the event. On the other hand, it may be preferable to carry out interviews in a quiet office where there will be fewer distractions. The decision, of course, may depend in part on the nature of the accident and the mental state of the witnesses. It will be useful to learn a number of do's and don'ts when interviewing witnesses. Of course, you should note that the purpose of the interview is to establish an understanding with the witness and to obtain his or her own words describing the event. So in order to get your interview up to a good start and to make it effective, ensure that you keep to some of these do's and don'ts. So in terms of things you should do, ensure you put the witness who is probably upset at ease, because it's not unlikely that the person injured or the accident may have affected this witness one way or the other. Maybe a co-worker is injured, or maybe some other close person to this witness, at least someone that the person knows has been impacted or may have been impacted by this accident. So put the witness who is probably upset at ease. Emphasize the real reason for the investigation to determine what happened and why, which is the real reason, and not to find fault. Let the witness talk, listen, and you listen. Confirm that you have a correct statement by repeating what the witness has said to them. Try to sense any underlying feelings of the witness. Make short notes or ask someone else on the team to take them during the interview, that is, notes. Ask if it is okay to record the interview, and if you're doing so, let them know that you're doing so, and of course, always close on a positive note. What do you mean by a positive note? A note of encouragement, a note wherein you let the person know that this is not a witch hunt. It is so that there is no recurrence and so that the system is improved. But what are the things you should not do? Don't intimidate the witness. Don't interrupt. Don't prompt the witness by asking leading questions. Don't show your own emotions, and also avoid jumping into conclusion when you are interviewing and asking questions from the eyewitness. Also, in order to elicit meaningful responses from the eyewitnesses, it's important to ask open-ended questions that cannot be answered by simply a yes or a no. The actual questions you ask the witness will naturally vary with each accident, but there are some general questions that should be asked each time. Some of these questions may include, where were you at the time of the accident? What were you doing at the time? What did you see or hear? What were the environmental conditions? So was it raining? How was the weather? Was the place well lit? Was there noise? And so on and so forth. Also, what were the injured workers doing at the time? Or another question could be, in your opinion, what caused the accident? Or how might similar accidents be prevented in the future? All of these are open-ended questions that actually help you to be able to effectively gather information from the witnesses towards coming to a good conclusion and recommendation down the line. The third and often an overlooked source of information can be found in documents such as technical data sheets, health and safety committee minutes, inspection reports, company policies, maintenance reports, past accident reports, formalized safe work procedures, and training reports. Any pertinent information should be studied to see what might have happened and what changes might be recommended to prevent recurrence of similar accidents. Having considered the first part of the accident investigation steps, which is information gathering, which included looking at eyewitness account, physical evidence, and background information, let's then consider analysis of the information gathered as the next step. Careful and complete analysis of the data collected following an accident is critical to the accurate determination of an accident's causal factors. The results of comprehensive analysis provides the basis for corrective and preventive measures. Note that the analysis portion of the accident investigation is not a single distinct part of the investigation. Instead, it is the central part of the iterative process that includes collecting facts and determining causal factors. Well-chosen and carefully performed analytical methods are important for providing results that can aid investigators in developing an investigation report that has sound judgments of need. Also, caution must be taken in applying analytic methods. First, no single method will provide all the analysis required to completely determine the multiple causal factors of an accident. Several techniques that can complement and cross-validate one another should be used to yield optimal results. Secondly, analytic techniques cannot be used mechanically and without thought. The best analytic tools can become cumbersome and ineffective if they are not applied to an accident-specific circumstances and adapted accordingly. Some analytic techniques are event and causal factors charting and analysis, barrier analysis, change analysis, as well as root cause analysis. The aim of analysis is to sieve all information gathered in order to reach a veritable conclusion. The four techniques that I just mentioned are typically used by investigators to analyze the factual information they have collected to identify conditions and events that occurred before and immediately following an accident and to determine an accident's causal factors. Once analysis has been concluded, then conclusions have to be drawn from the results of the analysis. Up until this point, it is expected that the investigator has kept an open mind to all possibilities and has essentially looked for all pertinent facts. It is now time to draw conclusions from the analysis that has been done. Each conclusion should be checked to see if it is supported by evidence, if the evidence is direct, that is physical or documentary, or based on eyewitness account, or if the evidence is based on assumption. This list serves as a final check on discrepancies that should be explained or eliminated. Conclusions should be organized sequentially, preferably in chronological order or in logical sets. They should be based on the facts and the subsequent analysis of the facts, include only substantive conclusions that bear directly on the accident, and ensure that you keep conclusions as short as possible. Conclusions are significant deductions derived from the investigation's analytical results. The process of determining conclusions seeks to answer the questions, what happened and why did it happen? So conclusions are derived from and must be supported by the facts plus the results of testing and the various analyses conducted. After the conclusions, then it's important to make recommendations. The most important final step is to come up with a set of well-considered recommendations designed to prevent recurrences of similar accidents. Once you're knowledgeable about the work process involved and the overall situation in your organization, it should not be too difficult to come up with realistic recommendations. Recommendations should be specific, constructive. They should address the root cause as well as identify contributing factors. It's important as investigators to resist the temptation to make only general recommendations to save time and effort. For example, you have determined that a blind corner contributed to an accident. Rather than just recommending eliminate all blind corners, it would be better to suggest install mirrors at the northwest corner of building X, which was the building probably wherein the accident occurred. And then you can go ahead and say install mirrors at blind corners where required throughout the work site. That is general. So you should give something specific and then something general to address all such issues that may be within the facility as well. Also note that you should never make recommendation about disciplining a person or persons who may have been at fault. This will not only be counter to the real purpose of the investigation, but it will jeopardize the chances for a free flow of information in future accident investigations. What we're saying here is that it is possible that at the end of the investigation, someone or some people or some personnel has been found to be at fault. While you're expected to reveal that and note that in your report, it is not part of the responsibility of the safety investigator to recommend punishment or disciplinary action towards such a person. So what then should be done to someone that is found to be at fault for an accident? It is important to note that after a thorough worksite accident investigation reveals that some person or persons among management, supervisors, and the workers were apparently at fault, then it should be pointed out as earlier said. The intention here is to remedy the situation and not to punish anyone. So when such things are pointed out, it may be a trigger for further training, or it may be a call for human resource to actually deal with such a person based on existing policies within the organization. Failing to point out human failings that contributed to an accident would not only downgrade the quality of the investigation, it would also allow future accidents to happen from similar causes because they have not been addressed. So it's important that such a person that is at fault is pointed out, but it is not the responsibility of the safety investigator to punish or to recommend punishment. Let's talk about the investigation report itself. The purpose of the investigation report is to clearly and concisely convey the results of the investigation in a manner that will help the reader understand what happened. That is, the accident description and the order in which the event actually took place. Why it happened, those will include the causal factors, and what can be done to prevent a recurrence, that is the judgment of need. So the purpose of the investigation report is to clearly present this to those that are going to make decisions as far as the recommendations towards ensuring that a recurrence does not occur is concerned. The investigation report constitutes an accurate and objective record of the accident and provides complete and accurate details and explicit statements of the investigation process, facts pertaining to the accident, analytical methods used and their results, conclusions of the investigators including the causal factors of the accident, judgments of need for corrective actions to prevent recurrence of the accident also. There are a number of useful strategies for drafting the investigation report and include things like establishing clear responsibilities for writing each section of the report if the investigation was done by a team, establish deadlines for writing quality review and production, also endeavor to use an established format, also use a single point of contact such as the administrative coordinator to control all electronic versions of the report including editing input and to coordinate overall report production. Also endeavor to start writing as soon as possible, write the facts as bulleted statements as they are documented, write the accident chronology as soon as possible to minimize the potential for forgetting the event and to save time when generating the first draft of your report. Also, if there are multiple investigators, ensure you share information with other investigators and also plan for several revisions. There are a number of other ideas that can help you generate good reports, but these are some of them. Generally, the final report should consist of the following elements: a disclaimer, table of contents including lists of exhibit figures and tables, a glossary of technical terms and acronyms if necessary. Of course, there should be an executive summary, the introduction, facts and the analysis, as well as conclusions and recommendations. Once the report has been submitted, of course, with the conclusions and the recommendations, then it becomes the responsibility of management to act on the recommendations and the accident investigation report. The Health and Safety Committee, if there is one, can monitor the progress of these actions to ensure that they are implemented. In this regard, follow-up actions would include responding to the recommendations in the report by explaining what can and cannot be done and why or why not, developing a timetable for corrective action, monitoring that the scheduled actions have been completed, checking the conditions of injured workers, informing and training other workers at risk, and reorienting workers on their return to work. Accident statistics are an important way of determining trends within an organization and of benchmarking the safety performance of an organization in relation to the national average for a comparative industrial sector. Essentially, it's important for your organization to know how you're doing in terms of your safety performance, and accident statistics help you to actually have a sense of where your organization is, whether your performance is improving, whether it is declining, or also to compare how you're performing in relation to other organizations within your country and generally around you or your industry. Trends are more important indicators of health and safety performance than individual accidents. In order to standardize accident statistics and to be able to compare the safety performance of one organization with another, there are a number of statistics, accident statistics that are kept, and we're going to look at a few of them. The first of these statistics is the accident frequency rate, which is the total number of accidents divided by the total number of person-hours worked times 100,000. The second is the accident incident rate, which is the total number of accidents divided by the average number employed during that period times 100,000. And the third one is the annual injury incident rate as calculated by the health and safety executive. This is the number of reportable injuries divided by the average number of employees times 100,000. Now, regulations would stipulate what constitutes reportable injuries. Talking about reportable injuries, the REDOR, which is the Reporting of Injuries, Diseases, and Dangerous Occurrences Regulations 2013, states that reportable injuries include the death of any person, specified injuries to workers as specified in REDOR, over 7-day incapacitation of a worker. All of these constitute reportable injuries. Also, non-fatal accidents to non-workers, e.g. members of the public. This also comes under reportable injuries, as well as occupational diseases. Over 3-day incapacitation, however, must be recorded, but it does not fall under reportable injuries, so it does not have to be reported. Under most jurisdictions, and of course under the REDOR as well, employers are placed under certain specific duties with regard to the reporting of accidents. In order to fulfill these obligations, managers and supervisors may be allocated certain roles and functions. And as earlier mentioned, they have to be adequately trained to be able to perform these roles and functions. Accident records should contain the following information: the date and time of the incident, full name and address of the persons affected, the person completing the entry, if different from anyone affected, as stated above, the occupation of the persons affected, the nature of the injury or condition, the place where the accident or incident occurred, as well as a brief but clear description of the circumstances, amongst other things. And finally, under REDOR as well, it's important to note that when a person not at work is involved in a reportable accident, then the name, status, and nature of injury must be recorded as part of the record. All of the discussions that we have had as regards accident investigation and reporting are essentially to help guide you when you are investigating and reporting accidents. Remember that we first started with considering what accidents are, and then we looked at the how of accident investigation, and then we looked at causation models. We also considered how to actually investigate accidents, looking at the 4 steps to investigating accidents, which included collecting information, analyzing, getting to a conclusion, and then making recommendations. When talking about collecting information, we talked about 3 ways by which we can do that, which included eyewitness account, physical evidence, and background information. Then we went on to discuss analyzing, and then we went on to discuss getting to a conclusion, as well as coming up with recommendations that will prevent recurrence of such accidents. And then we rounded up this discussion by looking at how to report accidents. And of course, the REDOR provides for us guidelines based on legislation for reporting accidents. Program elements, emergency procedures. So let's talk about emergency procedures. It's one of those areas that you also need to take care of as far as health, safety, and environment is concerned in the workplace. Remember, we've been talking about the elements that constitute a part of your defined plan of action in order to be able to effectively and efficiently manage safety in the workplace. So in this model, we will be looking at emergency procedures. So what are emergency procedures and how are they established? Emergency procedures are plans for dealing with emergencies such as fires, explosions, major releases of hazardous materials, violent occurrences, or natural disasters. When such events occur, the urgent need for rapid decisions, shortage of time, lack of resources, and trained personnel can lead to chaos. The objective of the plan is to prevent or minimize fatalities, injuries, and damage. The organization and procedures for handling these sudden and unexpected situations must be clearly defined, and that is why you must have emergency procedures or emergency planning as part of the program elements for your occupational safety and health plan or system. The development of the plan follows a logical sequence. This includes you compiling a list of the hazards, for example, fires, explosions, floods, attacks, natural hazards, and so on and so forth. Identifying the possible major consequences of each. For example, that there could be casualties, there could be damage to property, that there could be release of hazardous waste, and so on and so forth. Determine the required countermeasures. For example, that there will be evacuation, rescue, firefighting, and so on and so forth. Then inventory the resources needed to carry out the planned actions. That's step 4, which would mean you're looking at medical supplies, rescue equipment, training of personnel, all of the things that you'll be requiring to be able to carry out your countermeasures. So you need to inventory the resources that will be required. Based on these considerations, you then establish the necessary emergency organization and procedures, and then there is also a need to look at communication, training, and periodic drills that are required to ensure adequate performance when the plan must be implemented. Having listed the steps to creating an emergency procedure, as seen in the previous slide, it's also important to have an idea of the required element, that is, what are those things, the aspects or the resources that need to be available in order for the emergency procedure to be effective and for you to be able to carry out emergency response successfully. It's important to note that all projects or facilities or all work locations require an emergency plan. The magnitude, that is the size and complexity of the plan, depends on the size of the project or the facility. Some of the required elements include a method for reporting emergency. Generally, phone or telephone is the most effective. However, there should be an alternative that exists if the emergency disables the site phones, if it's landline, or if some way or in some form one is not able to access the telephone. So it's important that there is a backup to being able to contact emergency help or first responders other than the telephone or as an addition to the telephone. Also, there should be a list of workers responsible in emergency situations and how to contact them. This should be plainly posted. So these workers may be first responders within the facility, or they may be responders, either the fire service or some emergency team outside of the facility or outside of the project location. There should also be a plan for incident investigation and correction of hazard. A list of phone numbers for emergency and support services also should be available. This, of course, should be posted by the telephone or the place where the emergency call is to be made. There should be a method for sounding an alarm, such as an hair-on or warning bell. There should also be a description of potential emergencies. This is very important from an educational standpoint because it's important to be prepared for emergencies, as an emergency preparedness is essentially based on anticipating all possible situations. So it's important that there is a description of potential emergencies posted for people to have a high level of awareness of possible emergencies that may arise in a particular facility. Additional elements that make up what you need to have an emergency procedure would include a map of the workplace that shows evacuation routes, headcount location, which in some cases you call the muster point, as well as location of emergency equipment, first aid station, fire and fire extinguishers. This should be designed at the start of the job and posted where it will be visible. This also, if it's a facility that operation work goes on, then it should be designed at the inception of the facility or when risk assessment is done and posted in designations or places where there's high visibility and workers can really be able to see these information. The manager's routine for shutdown of the job should also be an element of the emergency procedure. This should be established to ensure that if a shutdown occurs, no potential hazard may be left. For example, ensuring that the power has been shut down before attempting an electrical contact rescue. A system for communication, both internal and external, two-way radios, telephones, or alarms should also be available. And also an evacuation, headcount, and rescue plan should also be made available. Rescues should only be attempted by trained persons. So it means that as part of the emergency procedure and emergency planning must also be training of persons that will be first responders. And the trained persons should only rescue only if they do not risk injury to themselves. Each supervisor should have a roll call system in place to ensure that all workers have been evacuated from the hazard area. You must note that emergency procedure and emergency response plan is actually a control method that stems from risk assessment. Later in this course, when we discuss risk assessment, emergency procedures, emergency response planning will come up again as part of the control methods and the response to risks that have been identified in the workplace. Finally, on program elements, we'll be looking at specific items. What do I mean by specific items? All of the elements we've looked at so far, accident investigation and reporting, safety inspection, correct work procedure, safety regulations, training, employee involvement, and so on and so forth, are items that are expected to be in every program, every plan of action, irrespective of the type of organization, the industry the organization operates in, irrespective of all of that. These elements or these parts of the overall health, safety, and environment plan are expected to be there. However, there are some other items or some other parts of the program that may be specific to different industries or different organizations, depending on the kind of work that organization carries out. So depending on the type of hazards that the organization is exposed to, then there will be some specific items that would be necessary that are to be included within your own program. And we are going to be mentioning some of those items in the next slide. As you can see, some of the specific items which may be needed to address workplace specific activities are items like workplace hazardous materials information system, lockout procedures, hot work permits, material handling rules, plant maintenance, fire safeguards, vehicle safety rules, off-the-job safety, working alone guidelines, PPE requirements, engineering standards, purchasing standards, as well as preventive maintenance. While this is not an exhaustive rule, the idea is to note that there are some specific items that may need to be included in the occupational health and safety programs that will be based on the specific risk assessment for those organizations or facilities. And you may have these programs in one organization but may not have them in another. But the earlier programs or program elements or items that we've mentioned in this section of the discussion are expected to be seen in practically all organizations. Welcome to section 4 of this course, Basic Certificate in Occupational Safety and Health, Level 2. Risk assessment is an interesting area of health, safety, and environment, and it's a very, very important area as well. In fact, as a safety professional, a fundamental area that you must have very good understanding of is risk assessment. Some may say that a safety practitioner should have a good grasp of the regulations subsisting in the jurisdiction within that person operates, and of course, industry knowledge, and also very good grounding in risk assessment, because you can say that everything as far as safety management is concerned rises and falls upon risk assessment, or everything starts and stops with risk assessment. So in this section, we'll be looking at risk assessment in depth. And risk assessment would include the following modules: introduction to risk assessment, hazard identification and analysis, risk controls, monitoring and reporting, hierarchy of controls 1, which would include introduction to hierarchy of controls, elimination, substitution, and engineering controls. Then there's hierarchy of controls 2, which would look at administrative controls. And finally, hierarchy of controls 3, looking at personal protective equipment. Risk assessment introduction. So in this module, I'll be introducing us to the concept of risk assessment, what it's all about, why we do risk assessment, and how to essentially start off on getting risk assessment done in your facility, on your project, or on different processes within your organization. As I mentioned in the introduction earlier on, I said that there is no more important skill to the safety professional than the ability to discover and remedy hazards before they can injure workers. And that essentially is the essence and the purpose of risk assessment, which is to discover circumstances, including at-risk behaviors or potential circumstances that may cause harm. And that is what we mean by hazard. Risk assessment actually is integral, and it helps to tailor the efforts of the organization to the peculiar risks within the organization, meaning that you are able to focus on the risks that are actually existing within your organization. So a risk assessment of the organization will throw up those things that pose a danger to the people within the organization, with the aim of the organization being able to remedy those risks before they are able to harm workers or they are able to damage assets. Program elements earlier treated as a result of risk assessment. I also mentioned this when we were discussing program elements, that the program elements that we threw up and that we discussed, including the fact that we said we need to come up with correct work procedures, rules and regulations, or safety rules and regulations, we need to have training, we need to have emergency response, and so on and so forth. All of these are actually as a result of risk assessment. So risk assessment is actually the starting point of every safety effort within your organization. Risk assessment is also seen, like I just said, the starting point to knowing what should be the exact action to take in your organization so as to be able to know how to manage safety effectively. Job hazard analysis, it's also important to note here that job hazard analysis is a job or task focused risk assessment, and I'm going to put a bit more or explain a bit further on what job hazard analysis is. Another question that one may want to ask is, why is risk assessment important? Risk assessments are very important as they form an integral part of a good occupational health and safety or health, safety and environment management plan. They help to create awareness of hazards and risks. They also help us to identify who may be at risk of any hazards within the environment. Risk assessment helps us to determine if existing control measures are adequate or if more should be done. The effort that is put into risk assessment also helps to prevent injuries or illnesses when done at the design or planning stage of a project or of a facility. Risk assessments also help us to prioritize hazards as well as have control measures. I would also like to quickly talk about job safety analysis or job hazard analysis, as some may call it. Now, job safety analysis can be considered as a type of risk assessment. It, however, has a much narrower scope, as job safety analysis involves only job-specific risks. Risk assessment, on the other hand, gives a big picture view of all operational risks, including environmental hazards and so on and so forth, within an organization or a project. Whereas job safety analysis is a formal process to identify the dangers of specific job tasks in order to reduce the risk of injury to workers. This then involves breaking down the steps of performing a job, identifying hazards at each step, and creating controls to keep workers safe while performing that task. A job safety analysis is sometimes referred to as a job hazard analysis, as I earlier said. So a job hazard analysis is focused on the job, and typically the outcome of a job hazard analysis will be what we call correct work procedures. There are 4 forms of hazard analysis. They include change hazard analysis, which is an analysis based upon a change in equipment or process. Process hazard analysis, which is analyzing an entire process rather than one job in that process. There's also phase hazard analysis, which is used when jobs or processes are rapidly changing. This often applies to construction. And of course, the last one, job hazard analysis, which is analyzing a specific job by analyzing its associated tasks. Having defined risk assessment and also having looked at hazard analysis, placing a bit of emphasis on job hazard analysis, and stating that job hazard analysis is a type of risk assessment but more narrow focused. Let's look at what risk is. Risk is the chance or probability that a person will be harmed or experience an adverse health effect if exposed to a hazard. It may also apply to situations with property or equipment loss. So what we mean by that is that the likelihood that someone is going to be hurt by exposure to a hazard and the extent to which that person will be hurt is what is considered as the risk. Okay, and so it also means that if we're looking at the likelihood, that is the probability of someone being hurt by exposure to a hazard and the effect of that hazard on the person, then it means that we actually have different degrees or different levels of risk. And simply put, risk can be depicted by these equations: hazard versus exposure. So risk can be looked at as the measure of hazard vis-a-vis the amount of exposure to that hazard. Risk also, and more often it's looked at in this way, that is severity versus probability, meaning the amount or the magnitude of the hazard, the effect the hazard has on the person, that's the severity of the hazard or the effect of the hazard on the worker, and the probability of exposure to that hazard. So risk is looked at as severity versus or times probability. A number of factors, as I've also just mentioned now, that influence the degree of risk would include how much a person is exposed to a hazardous thing or condition, and how, in what way the person is exposed to that hazardous condition. For example, breathing in some vapor or skin contact or ingestion. So the way the person is exposed may also impact on the kind of risk of exposure or the risk that hazard poses. Also, another factor is how severe the effects under the conditions of exposure are. All of these are factors that will be put into consideration to determine the level of risk that is present in a particular environment or that a particular hazard poses to the worker in the environment. Having looked at what risk assessment is and the importance of risk assessment, as well as the definition of risk, and in all of these, we have continued to mention the term hazard. So what is a hazard? A hazard is any source of potential damage, harm, or adverse health effects on something or someone under certain conditions at work. So a hazard is anything. It could be a substance, it could be a way of doing things, whether a process, it could be a condition that has the potential to cause harm. A common way to classify hazards is by categorizing hazards into biological hazards, chemical hazards, ergonomic hazards, physical hazards, psychosocial, as well as safety hazards. While this is not exhaustive, it is possible that you may find some other classifications in other texts or other courses. but this generally is acceptable as classification of hazards globally. As seen in the table, workplace hazards can come from a wide range of sources. For example, we can see it can be from a thing like a knife, and the harm it will cause is a cut. We can also see that workplace hazard can be a source of energy like electricity causing shock and electrocution, or a process like welding, wherein metal fumes are released, and also light that may be hazardous to the eyes if exposed to the naked eyes, and so on and so forth. Or a practice like hard rock mining, which can cause silicosis by reason of taking in some of the dangerous metals and fumes that may come from that practice. So a hazard can come from different activities or different items or different things within the work environment.
So in simple terms, a risk assessment is a thorough look at the workplace to identify those things, situations, processes, etc. that may cause harm, particularly to people and also to assets, like I said earlier on. After identification is made, that is identification of the hazards, then there's an evaluation of how likely and severe. Remember, when we looked at the equation of risk earlier on, it was severity versus probability or likelihood. Also, there was hazard versus exposure. And I did mention that more often than not, we use the relationship of severity versus probability or likelihood to determine the risk. Now, after identification is made, there's an evaluation of how likely and severe the risk is. And then one decides what measures should be in place to effectively prevent or control the harm from happening. And that is where we talk about our risk controls. This essentially is what risk assessment is. And that is what we'll be discussing for the rest of this section. But if you look at the table we have, it suggests some steps to risk assessment. First is to identify hazards and their potential for causing harm. Then to rank the hazards by priority, wherein you come up with a ranked list of hazards. How do you do that? You do that by determining what is the probability of the hazard causing harm and the severity of the harm it is going to cause. Later on in this model, we are going to talk about how to rank hazards by priority. Once that is done, then a determination of the hazard control measures will be done. And at the end of that particular step 3, a record of hazard controls, measures at various locations, adequacy of hazard control measures would be made. That is, you would have a list of what the controls for each of the identified risks are. Once this is done, then the next step will be to implement controls, the controls that have been determined. Then measurement of the effectiveness of controls would have to be an ongoing thing to ensure that the facility and the people, the workers within that facility, continue to be protected. And once measurement of effectiveness is done and certain discrepancies are found, then there will be a need, which is step 6, to make changes to improve continuously.
Risk assessment, hazard identification, and analysis. In this model, we'll be considering what are the steps and how do we go about identifying hazards and also analyzing these hazards. You'll recall that when we examined the 6 steps for risk assessment earlier on in an earlier model, we had talked about the first 2 steps to include hazard identification as well as analysis. Of course, we had earlier defined risks as the likelihood of hazards causing harm and the severity of the harm that the hazards will cause. So for us to be able to determine the risk, definitely the first step will be to identify the hazards within the specified space that we have scoped out to carry out our risk assessment. So that space could, for instance, be the workplace or the facility within which our organization exists. It could also be a project. It could also be an entire location or a department within an entire organization. So how are these hazards going to be identified? Essentially, hazards are identified primarily via inspection, okay, and also via looking at other documentation and essentially doing some sort of thorough investigation into a number of areas that you feel you can find information towards helping you discover hazards. So a number of the things you can do would be to look at all aspects of the work, including non-routine activities such as maintenance, repair, or cleaning. Also, you may want to look at accident, incident, or near-miss records or reports. You want to include people who work off-site, either at home, on other job sites, drivers that are mobile, moving around, and so on and so forth. So you essentially want to make sure, depending on the scope of the assessment you're carrying out, to cover all of the bases and all of the areas that hazards can emanate from. You want to look at the way work is organized or done, including experience and age of people doing the work, systems being used, and so on and so forth. Look at foreseeable as well as unusual conditions, for example, possible impact on hazard control procedures that may be unavailable in an emergency situation. What we're saying is that you want to look at unusual conditions that may give rise to some other hazards that would not be apparent under normal conditions. So peradventure, there's a power outage or there's an emergency situation. You want to be able to think about what are the possible hazards that can emanate from that or from those kind of conditions. Examine risks to visitors or the public. So aside from examining risks or the way workers may be exposed to hazards, you also want to think about people that are not familiar with that environment. So these are visitors or the public in general. So for example, if you're doing a project, maybe a construction project, or you're carrying out a mining operation or what have you, then you want to consider how that operation would also impact on other people that may not be directly involved with that work. Also, ensure in trying to identify hazards that you include an assessment of groups that may have a different level of risk, such as young people. Now, in this scenario, you're considering the level of exposure or the kind of exposure that some people may have to certain things. So you're looking at young or inexperienced workers, persons with disabilities, or new or expectant mothers. All of these are considerations that you want to make while identifying hazards. The key thing, however, is that the primary way by which we are able to identify hazards is by inspection. So it could be inspection of the workplace, it could be inspection of records, it could be inspection of how people are doing the work. You need to go and carry out inspections. It may also be inspection of documentation or even of video recordings. But whichever way you want to go to see how the work is being done, you want to go and see what is happening at the particular site where the hazard is likely to occur and harm people. So once the hazards have been identified, the next step is to analyze the hazards. And the aim of analyzing the hazards is so as to be able to rank or prioritize the hazards, so as to determine which hazard is the most serious and thus which hazard to control first. What that means is that you want to be able to check which of the hazards is the most likely to happen and also at the same time the most severe when it happens. So hazard analysis essentially has to do with checking the likelihood of occurrence of this hazard. Remember, hazard is anything that has the potential to cause harm. So you're checking what is the likelihood, what is the probability that this thing that has the potential to cause harm will actually happen, this event would actually happen, that it will cause harm. And then you're also checking if it does cause harm, how serious, how severe will the harm be. And so you use what you can see here, what we term a probability and impact matrix, or in some cases, some may call it a heat map, or you can call it a severity and probability matrix. It depends. You can call it any of those names, you'll be correct. And you'll see that it has been created such that it helps to compare the severity you determine that the hazard will cause and the probability that is determined that the hazard has. So we have the probability on the x-axis and the severity on the y-axis. So for instance, if a particular occurrence is decided that it is almost certain that this occurrence would happen, that is, the hazard is almost certain to cause harm, and it is also determined that the kind of harm that the hazard is going to cause is a major harm, then it means that we will find that particular hazard being ranked in the red box. You can see almost certain on the bottom, that is on the x-axis, and major on the y-axis, that is to my the vertical line. Then you find that major and almost certain meets in one of the red boxes, and that means that this risk is extreme risk. And so it means it will form one of those risks that you need to be careful about and you need to quickly find a solution or a control to. So what this matrix does is that it helps to determine which hazards are higher in ranking as far as risk is concerned, having considered their severity and probability, and which ones are low. And what that means also is that you want to say the ones that are low are things that do not pose a high threat to the safety of people in the workplace or to their health, and the ones that are extreme or high are those that pose a lot of threat, and you would want to control those first and ensure that they are brought based on the controls that you are going to administer, as we'll see later on. And you want to ensure that the risk level of those particular hazards are brought down to a very low state that is acceptable to you, or that they cannot harm the workers anymore. So generally, you would consider some of these factors when trying to rank or prioritize risks. You look at the percentage of workers exposed, the frequency of the exposure, the degree of harm likely to result from the exposure, as well as the probability of the occurrence. And of course, I've talked quite a bit on the probability and the severity being determinants of how you rank the risk. There's no one simple or single way to determine the level of risk. Of course, you would have guessed that the level of risk is represented by the low, moderate, high, and extreme. This is an example of a matrix that we can use to determine the ranking of the risks. Matrices can look different from this one that we have here. Some can be a 4x4 matrix. As we have here, we have a 5x5 matrix. Some can be a 3x3. But whichever way or whichever format you're going to use, it's important that you are consistent with what you're using, and across your organization, everyone that's going to be doing analysis of hazards is properly trained and familiar with the format that is in use within the organization. So there's no one simple way or single way to determine the level of risk. Ranking hazards requires the knowledge of the workplace activities, urgency of situations, and most importantly, there has to be objective judgment. This, of course, will come fair training and good knowledge of the risks within the environment and also the measure of probability. To determine the risk level, as we have in this diagram, we have low, moderate, high, and extreme. In some instances, you could also have very low. Very low risks typically will be considered as risks that are considered acceptable, and you do not require further action to ensure that the controls, or you only need to ensure that the controls are maintained. You could also have a measure of risk after very low tagged as low, where you don't need additional controls unless they can be implemented at very low cost in terms of time, money, and effort. That is to say that when also trying to reduce risks to the barest minimum, it is important that we take into consideration the cost that it will require to reduce the risk, especially if the risk is already considered a low risk. There is a concept in safety known as low as reasonably practicable, meaning that you want to reduce risk utilizing your controls to a level that is as low as is reasonable and is practicable. And that includes considering the amount of cost, time, and effort spent reducing that risk. Once you get to a point where there is what we call diminishing returns, meaning spending extra time, extra cost, extra effort in reducing the risk does not generate commensurate reduction of risk, then you have reached a point where you have gotten to as low as reasonably practicable. So at that point, you do not need to spend more effort to further reduce the risk. There's also moderate risk, which we can consider as a scenario where consideration should be as to whether the risk can be lowered where applicable to a tolerable level and preferably to an acceptable level. But also cost should be considered. The risk reduction measures should be implemented within a defined time frame when you find a moderate risk. Arrangements should be made to ensure that controls are maintained, particularly if the risk levels are associated with harmful consequences. For high risks, that is, hazards that have been determined to be high risk, then in scenarios like this, substantial effort should be made to reduce the risk. Risk reduction measures should be implemented urgently in high-risk situations. If a risk comes out to be of extreme risk in terms of the analysis, then these kind of risks are unacceptable and substantial improvements in risk control measures are necessary so that the risk is reduced to a tolerable or acceptable level. If in an extreme risk situation, it is important that the work activity is halted immediately until risk controls are implemented that reduces the risk so that it is no longer very high. If it is not possible to reduce the risk, such work that poses extreme risk to workers should remain prohibited. In this risk assessment matrix, there is an additional consideration when it comes to our consideration of severity or consequences, that we look at the element of people, element of assets, impact on community, as well as environment. And this particular matrix helps when looking at the hazard to consider what are the areas or the objectives that the hazards actually impact. And then there's also the element of increasing likelihood or probability and also severity. So the difference between this risk assessment template or matrix and the previous one is that this one looks at each of the hazards and considers the effect of the hazards on different objectives or different areas of interest for the organization. So this looks at people, so that when you're looking at the severity of the harm that the hazard can cause, then you consider how much harm it will cause to people, how much it will cost to assets, how much it will cost to the community and the environment. So that in determining the severity, you would not only consider just the harm to people, but you will consider the harm to people, assets, community, and environment. So it gives a more rounded view of how the hazard impacts on the business. And so it helps to determine that the severity level vis-a-vis the likelihood. And then when you look at the likelihood, for instance, in this diagram, you can see the blue region is the region where there is low likelihood versus low severity. The yellow region is a medium area where there is a need to control the risk to as low as reasonably practicable, as I mentioned. And the red region is the high risk region where risks that fall in there are not going to be tolerated. They would need to be reduced, and work that are related to this kind of risk may need to be stopped until something is done about them. risk assessment, risk control, monitoring, and reporting. In this model, we'll be considering and discussing risk control, risk monitoring, and reporting as part of risk assessment. Taking a cue from the previous model where we were able to identify hazards and also analyze the hazards using our probability and impact matrix, which consisted of the severity as well as the probability of the harm, that is the probability of the hazard causing harm and the severity of the harm the hazard can cause, which we represented on the matrix, and we're able to determine whether the risk is high, low, medium, extreme, or what have you. And we also considered some of the key objectives of the organization that the hazard may be impacting, which we called consequences. So in some instances, we were able to consider the impact on people, on the environment, on community, maybe on reputation, or on cost, or on assets, and so on and so forth. So once this has been established, that is, the top priorities have been established, then you can decide on ways to control each specific hazard. Hazard control methods are often grouped into the following categories: elimination, substitution, engineering controls, administrative controls, and personal protective equipment. And this has been listed in order of the most effective to the least effective. This is what is referred to as the hierarchy of controls. This strategy has proven to be very effective in the control of hazards in the workplace. Elimination looks at physically removing the hazard. Substitution replaces the hazard. Engineering control isolates people from the hazard. Administrative control changes the way work is done or people work. And personal protective equipment protect the worker with personal protective equipment that they wear on their bodies. Now, it is important to note that this strategy is very useful, and we'll be looking at it in more detail later on in this course. After the controls that have been listed or that were listed under hierarchy of controls have been created or developed and implemented, it is important that monitoring of the controls that have been implemented is done. Why is it important to review and monitor the assessment? This is so because if the risk assessment was complete and accurate, it is also essential to be sure that changes in the workplace have not introduced new hazards or changed hazards that were once ranked as lower priority to higher priority, meaning that the workplace is a dynamic environment, and what was not a hazard or a hazard of significant consequence at an earlier date may turn out, based on changes in conditions or situations or changes in certain new introductions into the work environment, they may turn out to then become hazards. So it is important that there is continual review and monitoring of the controls that have been put in place, and also continual assessment. And typically you will find that in most jurisdictions, it is advised that assessment be done, risk assessment of the facility be done probably quarterly or half yearly, or in some instances, particularly in critical areas where they are known to be high risk areas, risk assessment may even be done much more often. It is good practice to review risk assessment on a regular basis to be sure that nothing has changed and that control methods are effective. So triggers for review can also include the start of a new project, a change in the work process or flow, a change or addition to tools, equipment, machinery, including locations or the way that they are used. So also when there are new employees introduced into the organization, that also may be a reason to do a review. Peradventure, there's also a move to a new building or work area. Obviously, there will be a need to do a new risk assessment because it's a new environment. Introduction of new chemicals or substances to the work area or to the work process. And then when new information also becomes available about the current product. All of these are reasons why one may want to do a review. So it's important to continually review the risk assessment and to monitor the assessment for effectiveness, because things are dynamic in the work environment, and so there's a need for that. Another aspect of risk assessment is the reporting. It's important that after the hazards have been identified, analyzed, controls have been created and implemented, there is a need to also report. The level of documentation or record keeping that is required for risk assessment will depend on the level of risk involved, the requirements by legislation, and also requirements by any management system that may be in place. It is possible that your organization is aligning with some standards that may stipulate certain requirements of record keeping or reporting for risk assessment. But generally, the records should show that you have conducted a good hazard review, determined the risks of those hazards, implemented control measures suitable for the risk, and also reviewed and monitored all hazards in the workplace. Immediately after this model, you would find some sample risk assessments that have been done and some templates that you can use in carrying out risk assessment in your workplace. You'd also be required to do some exercises and assignments that would help you to further understand the concept of risk assessment in the workplace. Hierarchy of Controls, Part 1. In this Part 1, we'll be looking at introduction, just a brief discussion on hierarchy of controls, and also considering the elements of elimination, substitution, and engineering controls. As earlier mentioned, when we discuss the hierarchy of controls, the term hierarchy suggests that there are some controls that are preferred to others. And that's why you see in the diagram, we have the most effective controls to going down to the least effective control. So the most effective is elimination, while the least effective is personal protective equipment. And you'll find that a lot of times when people talk about HSE or safety, there's a lot of focus on personal protective equipment like hard hats, safety gloves, safety shoes, and so on and so forth. But it is obvious now that these are not the most preferred way of ensuring safety in the workplace. It is better preferred, or it is most preferred, that you are able to eliminate the hazard. Even though this is not always possible, but it is the most preferred. And the idea behind the hierarchy of controls is that in seeking to control hazards in the workplace, you look to the higher ranking controls first. So look to the possibility of eliminating, that is removing the hazard from the workplace, or substituting, which is replacing the hazard. If that is not possible, then you can consider engineering controls, which includes design or modifications to plants, equipment, ventilation systems, and processes that reduce the source of exposure. After engineering controls are considered, then you can look at administrative controls, meaning you look at engaging engineering controls, and peradventure there's still some residual risk left. Then you can look at administrative controls, that these are controls that alter the way the work is done, including timing of work, policies and other rules, work practices such as standards and operating procedures, including training, housekeeping, equipment maintenance, and personal hygiene. The last line of defense, or the last control to consider, then is personal protective equipment. These are equipment worn by individuals to reduce exposure, such as contact with chemicals or exposure to noise. Controls are usually placed at the source, that is where the hazard comes from, along the path where the hazard travels, at the worker where the hazard, of course, is going to do any sort of harm. Control at the source and control along the path are sometimes also known as engineering controls. As earlier explained, elimination is the process of removing the hazard from the workplace. This is the most effective way to control a risk because the hazard is no longer present. This is the preferred way to control a hazard and should be used whenever possible. The reality, however, is that this is not always possible. It is not always possible to remove the hazard from the workplace. And because it is not always possible to remove the hazard from the workplace, we're not always able to go with elimination, even though that is the most effective. For instance, if there is some sort of noise pollution in your environment, probably there's a machine causing noise in the work environment. Once you remove that machine, then it means that the work that the machine does will no longer be possible. However, it is possible to substitute that machine. Probably there is another machine that is not as noisy, then that would be substitution. Substitution and elimination at times are looked at as one and the same. That is, you've eliminated the old machine and brought in a new one. But that is better known or considered as substitution rather than elimination, because elimination would mean that the machine is no longer being used. Substitution occurs when a new chemical or substance is used, like I said in the example of the machine, instead of another chemical. It is sometimes grouped with elimination because in effect, you're removing the first substance or hazard from the workplace. The goal obviously is to choose the new chemical that is less hazardous than the original. As I mentioned earlier, there are scenarios where you really cannot eliminate or even substitute. For instance, if you're using a power generating set, you will not be able to substitute that. Well, possibly you may be able to substitute that probably with solar or with some other alternative energy. But if peradventure you do not have that, or you cannot afford that, and you have to use the power generating set, then you may need to find some other means of control of the noise that that particular generating set may be giving out. And there comes engineering control. Engineering control involves methods that are built into the design of a plant, equipment, or process to minimize the hazard. Engineering controls are very reliable ways to control worker exposure as long as the controls are designed, used, and maintained properly. The basic types of engineering controls include process control, enclosure, or isolation of emission source and ventilation. In the example I just gave of a generating set, a good way to control noise would be to put the power generating set, which ordinarily would make quite some noise, to put it within a soundproof cabin. In that case, you have not eliminated the noise, you have not substituted the noise, but you have isolated or enclosed the noise so that it is not able to reach the worker. Generally, the idea behind hierarchy of control and controls in general is that you find ways utilizing this 5 hierarchy of control elements to ensure that you're able to remove the hazard or to minimize the hazard and ensure that the hazard is not able to harm the worker. So in the example given as per the generating set and the isolation cabin, you find that we are able, because we're not able to remove the noise, okay, by elimination or substitute the generating set, we can enclose it. In some instances, you may even decide to locate the generating set far from where people are working, and that's what we mean by isolation. So in that case, you are isolating the emission source. And once you look through the hierarchy of controls, you can find interesting ways to ensure that the hazard is not able to harm people in the workplace. Hierarchy of controls, part 2. In this part, we'll be considering administrative controls and all of the ways by which we can carry out administrative controls. Administrative controls are not generally favored because they can be difficult to implement, maintain, and are not a reliable way to reduce exposure. And the key reason for this is because administrative controls typically would depend on whether the workers comply or not, or more on human behavior and the capacity or the ability or the compliance level of the worker. Unlike elimination, which physically removes the hazard, or substitution, which replaces the hazard, or engineering control, which isolates people and utilizes engineering means to sort of carry out process control, isolation, or ventilation, as the case may be, you find that administrative control is focused on limiting workers' exposure by scheduling shorter work times, for instance, in contaminant areas, or by implementing other rules. So administrative controls are rule-based. Okay, so we talk about standard operating procedure, schedules, and all of that. All of these depend on people complying. So they have limitations because the hazard itself is not actually removed or reduced. So as earlier mentioned, the higher ranking controls are more effective and they are preferred. Even though you find that you can use, in some instances, a combination of engineering controls, administrative controls, and PPEs. For example, in the generating set scenario that was set earlier on, where you have a generating set that is having a noise level beyond what is acceptable, you can decide that you will contain that generating set probably within a soundproof container. And then you find a scenario whereby even though you have that, you may still require that people still don't go near the generating set. That is an administrative control. You may still have signs, okay, near the generating set warning people of the hazard of noise if the soundproof container is opened. And you may still have a scenario where you still ask people to wear earmuffs in case the sound level has not been totally reduced. So you have scenarios where you can use a combination of engineering controls, administrative controls, or PPEs, either to ensure that people are totally safe or to take care of what we may consider as residual risk, even after some of the other controls, like engineering controls, have been instituted. So let's look at some methods of administrative control. These include scheduling maintenance and other high exposure operations for times when few workers are present, using job rotation, or using a work rest schedule. Going forward, we're going to look at a whole lot more administrative controls and look at them in more detail. Work practices are a form of administrative control. In most workplaces, even if there are well-designed and well-maintained engineering controls present, safe work practices are still very important. Some elements of safe work practices would include developing and implementing standard operating procedures, so these are considered under administrative controls, training and education of employees about the operating procedure, as well as other necessary workplace training. These are administrative controls because they aim at amending or affecting the worker's behavior in a way that would ensure that the worker is safe. Establishing and maintaining good housekeeping programs, keeping equipment well maintained, and preparing and training for emergency response for incidents such as spills, fire, or employee injury are all considered administrative controls under work practices. As mentioned under work practices, education and training is also one of the administrative controls that you can implement to control hazards. Employee education and training on how to conduct their work safely helps to minimize the risk of exposure and is a critical element of any complete workplace health and safety program. Now, you will recall that earlier on in this course, under section 3, when we were talking about program elements, education and training happened to be one of the program elements. In fact, you will find that administrative controls, the elements that we have under administrative controls, oftentimes will be things that are in the program element because Having an occupational safety and health management system in itself is actually an administrative control because it contains procedures, regulations, and guides on how to amend or affect the behavior of workers within the workplace to align with occupational health and safety requirements. So you find that a lot of the administrative controls that we will be talking about, we had earlier talked about them under program elements when we were discussing having a defined plan of action to manage safety effectively in an earlier section. So training must cover not only how to do the job safely, but it must also ensure that workers understand the hazards of their job. It must also provide them with information on how to protect themselves and their co-workers. Good housekeeping is also an administrative control, and it is essential to prevent the accumulation of hazardous or toxic materials, that is build-up of dust or contaminants on ledges or beams and so on and so forth, or to prevent hazardous conditions, e.g. poor stockpiling. So good housekeeping also falls under administrative controls in the hierarchy of controls. Another administrative control is emergency preparedness, and if you recall, this also featured quite significantly in our discussion on program elements. Being prepared for emergencies means making sure that the necessary equipment and supplies are readily available and that employees know what to do when something unplanned happens, such as a release, a spill, fire, or injury. These procedures should be written, and employees should have the opportunity to practice the emergency response skills regularly. So emergency preparedness, emergency response planning is actually an administrative control as well. Emergency procedures are plans for dealing with emergencies such as fires, explosions, major releases of hazardous materials, violent occurrences or natural hazards. And when such events occur, the urgent need for rapid decisions, shortage of time, lack of resources and trained personnel can lead to chaos. The objective of the plan is to prevent or minimize fatalities, injuries and damage. The organization and procedures for handling these sudden and unexpected situations must be clearly defined, and that's essentially what you call the emergency response plan. The development of the plan follows a logical sequence. 1. Compile the list of the hazards, then identify the possible major consequences of each identified or listed hazard. Determine the required countermeasures, for example, evacuation, rescue, firefighting. Then inventory the resources needed to carry out the planned actions, like medical supplies, rescue equipment, training, personnel. And then based on these considerations, establish the necessary emergency organization and procedures, and finally ensure there's communication, training and periodic drills, which are required to ensure adequate performance when the plan must be implemented. It's important to note that all projects or facilities require an emergency plan. The magnitude and complexity of the plan depends on the size of the project or workplace, and we've looked at the steps for creating an emergency plan. It's also important to consider the elements that are required within a plan that is created. You should have a method for reporting the emergency. Generally, telephone is the most effective. However, an alternative should exist if the emergency disables the site phones, particularly if they are landlines and phones that can be disrupted as such. There should be a list of workers responsible in emergency situations and how to contact them, and this should be plainly posted. Also, part of what you expect to have in your emergency plan is a plan for incident investigation and correction of hazard. Also, a list of phone numbers for emergency and support services should be posted, typically by the telephone. A method for sounding an alarm also should be available, such as an air-on or warning bell. There should be a description of potential emergencies. This is extremely important from an educational standpoint. Emergency preparedness is essentially based on anticipating all possible situations. Also, part of what you expect to have within your emergency plan is a map of the workplace that shows evacuation routes, headcount location, as well as location of emergency equipment. Headcount location is what you typically call your muster point. Also, it should show the first aid station, fire extinguishers. This should be designed at the start of the job or at the initial period of establishing a facility and posted where visible. The manager's routine for shutdown of the job should also be available. This should be established to ensure that if a shutdown occurs, no potential hazard may be left. For example, ensuring that the power has been shut down before attempting an electrical contact rescue. You should also have a system for communication, both internal and external. Two-way radios, telephones, or alarms should be available. An evacuation headcount and rescue plan also should be available, and rescues should only be attempted by trained persons and only if they do not risk injury to themselves. Each supervisor should have a roll call system in place to ensure that all workers have been evacuated from the hazard area. Administrative controls also include personal hygiene practices. These are another effective way to reduce the amount of hazardous material absorbed, ingested, or inhaled by a worker. They are particularly effective if the contaminants can accumulate on the skin, on clothing, or hair. Examples of personal hygiene practices include washing of hands, avoiding touching lips, nose, and eyes with contaminated hands, no smoking, drinking, chewing gum, or eating in the work areas, especially if it's an area where the kind of work that is being done can contaminate food. And then not placing strong hazardous materials in the same container or refrigerator as food items. These are all personal hygiene practices that can help in ensuring that people are kept safe in the workplace, and they are considered administrative controls. Another administrative control that is worthy of note is the permit to work system, which is a formal recorded process used to control work which is identified as potentially hazardous. It is also a means of communication between site or installation management, the plant supervisors and operators, and those who carry out hazardous work. Now, we have a course that is focused on permit to work, and to know more about permit to work, you can check out our course on permit to work. Safety signs and signals are also administrative controls. Safety signs and signals are one of the main means of communicating health and safety information. And remember, administrative controls are geared towards aligning how people work in order for them to stay safe. So safety signs and signals come in there to help give instruction, give warning, provide restrictions, or give instructions as per restrictions, and so on and so forth. So safety signs and signals are important, and they come in here as administrative controls. Some jurisdictions have regulations guiding the use of safety signs and signals. An example is the Health and Safety Signs and Signals Regulation 1996 of the UK. These regulations require employers to provide specific safety signs whenever there is a risk that has not been avoided or controlled by other means, e.g. by engineering controls and safe systems of work. According to this regulation, where a safety sign would not help to reduce that risk, or where the risk is not significant, there is no need to provide a safety sign. There are specific requirements for the shape, color, and pattern of safety signs, and this is important. Any sign must contain a symbol or pictogram and be of a specified color which clearly defines its meaning. Supplementary text may also be used to aid understanding, but text-only signs are not permitted. Note that these stipulations are according to the regulation earlier mentioned. In your jurisdiction, there may not be any such restrictions or any codes for safety signs. But these signs that we'll be seeing later on are actually global best practices that give an indication of how signs should be, and it could also help you to be able to identify signs and signals when you see them. Where signs are used, employers must ensure signs are maintained. Any defective or faded signs should be replaced. They should also explain unfamiliar signs to employees to ensure they understand the meaning and actions to be taken in connection with them. The regulations apply to all places and activities where people are employed, but exclude signs and labels used in connection with the supply of substances, products, and equipment, or the transport of dangerous goods. As signs and signals are main means of communicating health and safety information, they include generally use of illuminated signs, hand and acoustic signals, for example fire alarms, spoken communication, and the marking of pipework containing dangerous substances. Traditional signboards such as prohibition and warning signs, signs for fire exits, fire action plan, and all of such signs are included under signs and signals. Of course, it's important that signs and signals are easily understood. And in the following slides, we're going to see some of the standard signs and signals based on the regulation earlier cited. This is a prohibition sign, essentially showing that some unauthorized behavior is not permitted in this environment or where the sign is placed. It should have a round shape, a black pictogram on white background, red edging and diagonal line, the red part to be at least 35% of the area of the sign. So it is expected that this is consistently used in this way, and it becomes easy for people to recognize once they see this, that this is what this sign is trying to pass across. Then there is the warning sign. The color typically is yellow or amber, and the information this is trying to pass across is be careful, take precaution, examine. It typically would have a triangular shape, black pictogram on yellow background with black edging, yellow part to be at least 50% of the area of the sign. You can see some of the signs we have illustrated here is warning for biohazard, warning for radioactive material, and also general warning. There's also the mandatory behavior sign, which is blue. This sign is passing across the information that specific behavior or action is required. For example, wearing or donning of personal protective equipment. This sign is round shaped with white pictogram on blue background, the blue part to be at least 50% of the area of the sign. And in the depiction we have here, you can see several mandatory behavior being required, like wearing of goggles, earmuffs or hair protection, hard hats, as well as other PPEs. There are other signs as well that show emergency escape, first aid, and generally no danger. And the idea and the information these signs that are typically green are trying to pass across is to show doors, exits, and escape routes. They're rectangular or square shape, white pictogram on green background, green part to be at least 50% of the area of the sign. And lastly, on our discussion on signs and signals as far as the standard signs are concerned, are the firefighting equipment, which are also depicted by red signs. And the information that these signs pass across is the identification and location of firefighting signs. They're typically rectangular or square shape, white pictogram on red background, red part to be at least 50% of the area of the sign. And of course, it is important to then note that signs and signals are very useful in ensuring effective management of safety and health in the workplace. And they're essentially a hazard control mechanism to ensure that behavior is enforced or is communicated more like in the workplace for there to be adherence to safety and health regulations, instructions, and provisions that have been made for the safety of the worker in the workplace. Hierarchy of controls, part 3. Here we'll be looking at personal protective equipment. Remember that in our hierarchy of controls, we have at the top of the hierarchy elimination, then substitution, then engineering controls, then administrative controls, and then personal protective equipment. So in this model, we'll be examining personal protective equipment. Personal protective equipment is the last means of protecting workers from injury. PPE is only employed when administrative and engineering controls are ineffective or insufficient. Hazards should be minimized by ensuring that all jobs are well planned, workers are properly trained, and safe work practices and safe job procedures are followed. All of these, of course, are administrative controls. PPE provides an additional degree of protection from injury. Personal protective equipment, PPE, includes items such as respirators, protective clothing such as gloves, face shields, eye protection, and footwear that serve to provide a barrier between the wearer and the hazard. It could be chemical or some other material. PPE is the final item on the list for a very good reason. PPE should never be the only method used to reduce exposure, except under very specific circumstances, because PPEs may fail, that is, stop protecting the worker with little or no warning. For example, a breakthrough can occur with gloves, clothing, and respirator cartridges. PPEs generally fall into two categories, basic and specialized. The PPE that should be worn at all times by all personnel in the workplace is considered basic PPE. This would include hard hats, safety glasses, safety footwear, and appropriate clothing. Specialized PPEs cover PPEs which are used only for specific jobs or for protection from specific hazards. This includes gloves, welders, goggles, respiratory protective equipment, fall arrest equipment, as well as special clothing. Let's consider eye and face protection as a type of PPEs. There are two types of eye and face protection. There's the basic eye protection, and then there is the face protection. This general class of PPEs are designed to protect the worker from such hazards as flying objects and particles, molten metals, splashing liquids, ultraviolet, infrared, and visible radiation, typically from welding. So for basic eye protection, we have eye cup goggles, monoframe goggles, and spectacles with side shields. For face protection, we have metal mesh face shields, chemical and impact resistant face shields, welder shields or helmets with specified cover, filter plates, lenses, hardened glass prescription lenses, and sports glasses are not an acceptable substitute for proper required industrial safety eye protection. In the use and administration of eye protection and face protection, there are a number of things to note, to do and not to do. Ensure your eye protection fits properly close to the face. These are things that you ought to do when using eye protection. Ensure you clean safety glasses daily or more often if needed. Store safety glasses in a safe, clean, dry place when not in use. Replace pitted, scratched, bent, and poorly fitted PPE, of course safety glasses included. Damages to the face eye protection interferes with vision and will not provide the protection it is designed to deliver. So it's important to replace eyeglasses that may be damaged or pitted. Do not modify eye or face protection, and don't use eye or face protection which does not have a proper certification. There are various markings or the safety stamp for safety glasses, which are usually on the frame inside the temple near the hinges of the glasses. So you should note the appropriate eyewear or eye protection to use for different scenarios, as it will be stipulated on the particular eye goggles or eye protection that has been procured. Safety footwear is designed to protect against foot hazards in the workplace. Safety footwear protects against compression, puncture injuries, as well as impact. Safety footwear is divided into 3 grades, which are indicated by color tags and symbols. The tag color tells the amount of resistance the toe will supply to different weights dropped from different heights. That is the toe protection, the hard toe, the protection at the toe of the footwear. The symbol indicates the strength of the sole. For example, a triangle means a puncture-resistant sole able to withstand 135 kilograms of pressure without being punctured by 5 centimeter nail. The choice of protective footwear should always overprotect and not underprotect. This also tells us that you must pick the right protection for the particular job at hand or the anticipated risk that workers are going to face in that particular work environment. So an understanding of what the tags and the symbols represent will be very useful in picking or in choosing the best foot protection for particular jobs and for particular workers in particular organizations. A few do's and don'ts for protective footwear or safety footwear or safety boots as we like to call it. Ensure you choose footwear according to the job hazard and approved standards. Ensure you lace up boots and tie laces securely. Boots do not protect if they're a tripping hazard by themselves or if they fall off, so it's important to lace up your boots and ensure they're secure. Use a protective boot dressing to help the boot last longer and provide greater water resistance. Wet boots, of course, conduct electricity. It's also important if you are anticipated to work in an environment where there will be electricity or exposure to electricity, then the kind of boots that should be chosen for that environment should be appropriate for the environment. For instance, the kind of boots that people that work and they have to climb electric poles and electric installations wear must be, of course, electricity resistant. Choose a high-cut boot to provide ankle support. This would help to minimize injuries and protect much the ankle part of the legs. Do not wear defective safety footwear, that is, those that have exposed steel toe or caps. Do not underprotect your feet, and do not modify safety footwear. Safety headwear is also an important PPE that is considered one of the basic PPEs that should be used in the work environment, especially where there's a danger of falling objects or dropping objects from a height. Safety headwear is designed to protect the head from impact from falling objects, bumps, splashes from chemicals or harmful substances, and contact with energized objects and equipment. Most head protection is made up of 2 parts: the shell, which is light and rigid to deflect blows, and the suspension, which is meant to absorb and distribute the energy of the blow. Both parts of the headwear must be compatible and maintained according to manufacturer's instructions. If attachments are used with headwear, they must be designed specifically for use with the specific headwear used. Bump caps or laceration hats are not considered safety helmets. It is important that the appropriate choice of safety helmet is made for the appropriate work. There are different classes of safety helmets. We deal with the classification of safety helmets in our level 3 course. Proper care is required for headgear to perform efficiently. Its service life is affected by many factors, including temperature, chemicals, sunlight, and ultraviolet radiation from welding. The usual maintenance for headgear is simply washing with a mild detergent and rinsing thoroughly. Let's have a look at some do's and don'ts for headgear or safety helmets. Ensure you replace headgear that is pitted, pulled, cracked, or brittle. Replace headgear that has been subjected to a blow, even though damage cannot be seen or it's not visible or not apparent. Remove from service any headgear if its serviceability is in doubt. Replace headgear and components according to manufacturer's instruction. Consult regulations or your supplier for information on headgear. Ensure that you do not drill, remove picks, alter the shell or suspension of safety helmets in any way. Don't use solvent or paint on the shell. These make the shell to break down. Do not put chain straps over the brims of certain classes of headgear. Don't use any liner that contains metal or conductive materials. Don't carry anything in the hard hat while wearing the hard hat. So essentially, under PPEs, we have considered generally basic and specialized PPEs as the main types of PPEs, and we've looked at eye protection, as well as foot protection, as well as head protection, and these are considered as basic PPEs that are regularly worn in the workplace. Now, it's important for us to also consider the concept of behavior-based safety. Earlier on, I had mentioned that administrative controls and PPEs are quite dependent on the behavior of the worker to ensure their effectiveness. And the idea is that as you move further down the hierarchy from elimination to PPE, you are depending more and more on the compliance and the behavior of the workers to ensure the effectiveness of the control. Due to this relationship between the effectiveness of control measures, particularly administrative and PPEs, administrative controls and PPEs, it is important that as safety professionals, we understand the concept of behavior-based safety. Behavior-based safety is the application of behavioral science knowledge and techniques to control at-risk behaviors and prevent accidents in the workplace. It means that in order for the safety officer or the safety professional to be able to get or encourage or motivate people in the work environment to align and adhere to safety measures and to ensure that they are able to have these measures effectively implemented within the workspace, then the safety practitioner must understand the concept of behavior-based safety. And there are 4 general at-risk behaviors that cause most accidents that when we understand, we will be able to nip this kind of behaviors in the bud and so impact on the effectiveness of the safety programs that have been put in place. The 4 general at-risk behaviors that cause most accidents include eyes not on task, mind not on task, being in the line of fire, and body position. Essentially, eyes not on task implies that the worker is not concentrating. Mind not on task implies that the worker is distracted, probably thinking about something else, or is not in the correct state of mind to do the work. Being in the line of fire, talks about a worker being in a place where it is easy to get injured. For adventure, someone that goes to have lunch under a building where construction is taking place and there can be falling objects, or someone that stays and is making calls in the path where probably a forklift is going to be reversing. These are scenarios of being in the line of fire. Or body position, which talks about seating position, posture essentially as it concerns working, and these are ergonomic related risk factors. Now, these 4 general at-risk behaviors are those that have been seen to cause most accidents. When this is considered in regards to behavior-based safety, then if the safety professional or the supervisor is able to identify this and is able to take care of this with the workers, then it means that a lot of accidents will not occur, because issues of eyes not on task, mind not on task, being in the line of fire, and body position have been taken care of, and so a lot of hazard accidents would actually not occur. In the same vein, there are 4 states of mind that cause or contribute to the 4 general at-risk behaviors. These include rushing, frustration, fatigue, and complacency. So the idea of behavior-based safety is that the safety professional or the supervisor, once that person realizes that these states of mind cause or contribute to the 4 general at-risk behaviors, and they are able to address this either by programs, by training, by awareness, they would have managed to reduce accidents in the workplace based on their effort at behavior-based safety. Now that you have completed the Basic Certificate in Health, Safety and Environment HSE Level 2, the next step is to enroll for the Advanced Certificate in Health, Safety and Environment HSE Level 3. Some of the topics that we will discuss in the HSE Level 3 would include chemical safety, personal protective equipment in more detail, lockout, tagout, machine guarding, fall protection, fire egress and first aid, confined space entry, electrical safety, bloodborne pathogens, ergonomics, hazardous materials, workplace violence prevention, as well as adult training skills. Thank you very much for being a part of this HSE Level 2, and I look forward to you joining us in HSE Level 3 to move your career as a safety personnel from basic to advanced to the pro level.